Good afternoon, good very early morning, depending on where you are, and we are delighted to have you here today for this workshop slash webinar on underwater radiated noise and shipping. I just wanted a couple of quick housekeeping things. The cameras and microphones are not functional as part of this instance of Teams, but we just very much encourage folks to use the Q&A function for questions and comments. We will be monitoring them throughout, aggregating, collating, and trying to get questions answered as much as possible. We are recording, and so that will also be captured in that. The chat function is not as straightforward in terms of capturing it, so please don't use that for questions and answers. Please use the Q&A. And again, we want to really encourage engagement and questions and so forth, and that's part of why we've set it up as a multiple event so that we can get back to some of those questions tomorrow and throughout the workshop. And several of us will be in the background working on those. You can please do go to the Game On website and see who's involved in this session and in the past workshops. And then just again, it will be recorded and we will post it to the website once it's cleaned up and ready to go. Okay, I think that's all the housekeeping. Again, many thanks for joining. Just have a few slides to introduce Game On itself, the theory and the vision behind it, and a little bit about it before we get going into the meat of the webinar and workshop. Okay, so Game On started very organically with several of us on different panels and different groups that were talking about ocean noise and how to approach it, how to manage it, how to mitigate it, and realized there was a space, a niche for an organization, initiative, whatever you want to call it, that is truly multi-stakeholder, truly focused on bringing up action that can be taken, and getting everybody that we can around the table to talk about these things so that nobody feels like they're on the table and everybody feels like they're represented. The original workshop that we had at IUCN several years ago now had folks from industry, from NGO, from government, from academia, across the board, again, to really drive home that need for representation for everyone. The vision you see there is very simple: to achieve a quieter ocean where marine life and human use thrive. And the mission is to drive responsible, modern, and informed solutions for managing difficult ocean noise issues by harnessing a global, multi-sectoral alliance of partners, solutions, and networks. And I think you'll see throughout this webinar and this one, and if you look at the previous ones, you'll see that I think we've managed to assemble some great panels and some great discussions on it. All right, Juliet, if you could just next slide, please. Thanks. So just a bit about the core values. We really work to integrate science, technology, policy with industry and monitoring efforts to look across the landscape, the seascape of ocean noise, identify current concerns as well as emerging ones, concerns and solutions. And then we also want to map whatever knowledge that we do have on things with the various aspects of it, from the technology, the policy, and get a map of those things. And again, we realize this is international. You see the international representation that we have in the presentations, as well as the multi-sectoral part of it. So this is all part of this mapping, and also to create inclusive dialogues, expand our own networks to folks that aren't the usual suspects for the people that we tend to hang out with for in our professional lives, and to expand that into others that can help us or we can help them to approach some of these things. So, and then you see there listed our core values, and I won't go through them all. Hopefully they're self-evident, and hopefully we are portraying those through this work. All right, next slide, please. Okay, how it works. We, as I mentioned earlier, we convened a pretty small workshop of folks, again, from across sectors to really scope out how we wanted to organize, how we wanted to operate. And that has, of course, evolved over the years. And anybody's welcome to join. We have what we call a sounding board as our sort of core group to get together and toss ideas around. what are we going to do next? How are we going to handle shipping noise versus other noise sources, et cetera. And again, to foster those dialogues, but really to fuel those workable, creative solutions to approach and hopefully transform what have been seen as intractable ocean noise problems. We're not a consultancy, a research organization, an advocacy group, or a standard setting body. We recognize the need for governments and regulators to come up with standards and targets. And we certainly want to help do that, realizing the national versus international flavor of that in terms of what the national governments have to actually do for boots on the ground, or fins in the water, I guess I should say. By virtue of having this large network, we amplify our ability to identify and find efforts that are ongoing and existing worldwide, and try to help incorporate those into what we're trying to do. And among other networks that have come about since we started talking about Game On is the one that Juliet and company at the Bureau of Ocean Energy Management in the U.S. Has helped to organize is MONMER, this international regulators forum. So that's the kind of thing that's a forum for them to meet and talk and bounce things around. But we've presented some of this work to them, again, just to keep those networks well connected and synergizing with one another. And the last thing is really driving partnerships to inform, empower, and advance timely action. And that's one of the key things that we really try to keep a focus on action. We leave time at every meeting to scope out what are the next actions that can be taken. What do we need to do to be in place to put those actions into effect to overall reduce the impacts of ocean noise. Okay, next slide, please, Juliet. All right, so we did publish we wrote up a report from our initial meeting, but since then, with of course COVID intervening, our plan had been to have a series of workshop webinars. As you see here, we first tackled offshore renewable energy development, and then seismic exploration and geophysical and geotechnical exploration, and then the shipping workshop that we're having now. And the idea was that once we had these, we would have an in-person summit to try and merge the solutions that can be merged, look for actions that could be taken quickly, or ones that could be implemented over the years. But this is where we are right now, and we're going to spend some time talking about it. And again, I thank you very much, all of you, for attending, and particularly to our presenters and panelists. And with that, I'm going to hand it over to Brandon Southall and Leela Hatch.
Great, thanks so much, Doug. Julia, can you hear me okay? And could you skip forward a couple slides?
Yes, loud and clear.
Okay. Great. Yeah, thanks so much, Doug. My name's Brandon Southall. I'm going to go first and hand it as quick as I can to Leela Hatch. We're both involved in Game On, and Leela has really been very centrally involved in this issue, and I've been historically involved in it, and I'm going to share some sort of initial perspectives on a couple points leading into this, and some history of how we got here. Next. Yeah, first, just a little bit more detail on this specific workshop, what we're trying to do, and there's really sort of two components to it. One is a detailed look, and this webinar is substantially 3 times longer, I think, than the previous ones, in part, and happened last in the series, in part because of how much work internationally is happening on it, which is really exciting to see in some of the progress and the direct and quantifiable accomplishments towards targets that have been set is really exciting to see. So we'll look at some of those specific initiatives and how they're achieving those goals for reducing underwater radiated noise from vessels, which you'll hear people use the term URN probably multiple times today. So one of the things I think is good and that we tried really hard in putting this together is to pull across nations, and that's a really key part of Game On is to really look at where this is and where this is going internationally, and getting the right stakeholders involved, and current best practices will be a key part of that assessment of current work. Then the second key component is facilitating cross-jurisdictional discussion and dialogue on how these things get implemented. The more awareness and global collaboration and discussion we can have, I think is really helpful, looking at lessons learned and what works and what's challenging. Insights on differences between regulatory processes, which, as Doug said, is kind of inevitable, but the more we can discuss and consider how those exist, what best practices are, and leveraging the kind of processes that have worked across jurisdictions is another key goal. Next slide. Just a quick overview. You should have access to the agenda, but in the sessions today, there'll be two sets of presentations. The first one looking at new insights on target setting through new measurement prediction techniques, validation. The second one will look on target setting in terms of implementation. And then tomorrow there'll be a cross-jurisdictional panel of people from different places and different disciplines that helps us move forward with these objectives in ways that encourage and support innovation, that encourage those who are adopting best practices to be recognized, and that allows for transparent and understandable and quantitative tracking of progress towards quieter operations. As Doug said, we want engagement. We want questions and comments. Put them in the chat. We'll track them, and that will actually be something that will help us align the conversation. And there will be time for discussion, and we'll address as many of those questions and comments as we can. Okay, next slide. All right, I just have a couple of kind of maybe big picture, take a step back, look across the arc of this topic, kind of perspectives that I'm going to share, and some of them that have kind of called for, driven the quest for thresholds in the context of target setting. So, just in the biggest big picture, it's been identified, at least within the scientific realm, that the potential for vessel noise to impact marine mammal communication, specifically whale sounds, has been identified for at least 50 years. But really, the direct engagement with the industry, international awareness, and the kind of partnerships and efforts and incentivization programs has really only been in about the last 20 years. And for those of you that haven't been involved in other underwater noise issues, I think constructively this issue has been one that hasn't had the kind of historically contentious, litigative, finger pointing, siloed kinds of discussions that have been involved in other issues. Some of those have definitely gotten better through dialogue and through discussion, but this issue has, I think, from the start been more constructive, more progressive, more of a multi-stakeholder kind of conversation, and I think that is in the spirit of what Doug described as what we've been trying to do with Game On. So I think events like this have helped, and there've been many other ones that I think that have helped set that tone for this to be more in that kind of space where we listen to people from different perspectives and different voices, and I think that's a good thing just in the context of this. So, but as we started addressing this issue, some of the key questions that came up right from the beginning, from the engineers or from the regulators or just from all sides were really kind of, what's the threshold of impact? At what point do we hurt or disturb or interfere with communication, i.e. masking for marine mammals from shipping noise? And given the scientific uncertainty and given just the biological realities that I'll talk about on the next slide, that turns into a really difficult way to kind of address the issue from a regulatory point or from an engineering perspective. But one of the other early points and objectives was, and they're related, but was specifying targets either at the vessel level, at the category of vessels, or in some sort of spatial geographic sense. They're kind of intertwined a little bit, and the first one has made the second one a little bit harder. Next slide. So I've been involved for a long time with this question of thresholds, and we kind of call them noise exposure criteria to get at these thresholds. I spent my time within the regulatory agency in the US trying to help develop these kind of threshold based approaches for direct physical injury from noise exposure and behavioral disturbance. And in 2007, well, from about 2003 to 2007, a group of a bunch of people met together to really try and address that question for the first time in a systematic way. And there was a couple of accomplishments that came out of that. One was we grouped the animals into different hearing groups, and not exactly taxonomically, but based on how we knew or we thought that they heard. And one key but obvious thing from that is the frequency sensitivity of the animals as it relates to the activity, to the noise that you're talking about really matters. But did that in a systematic way. We did come up with thresholds for the most kind of intense effects, meaning sounds that are loud enough to cause physical injury, either temporary damage or physical injury. But there's a couple nuances in that. There are two sound metrics. There were impulsive and continuous criteria, and they differed for each of the hearing groups. So even where you have a threshold, we'd have a single threshold. There's kind of these contexts of the signal and the animals that really matter. And I think importantly, there was a conclusion that the available science definitely did not support a single numeric threshold for behavior. I know that table is a little small up there, but it's one of a number of tables that we had where we looked at the exposure received sound level as a function of the severity score, the relative magnitude of a kind of response. And if you look across a whole bunch of individuals, you see that there's not a point where below it's 0 and above it's 100. In fact, it's quite distributed, and you get these differences between species. This was grouped across baleen whales for impulsive sound, but you get these species differences and context differences and things that are just biological reality that make it difficult to come up with a single number. So in that 2007 paper, we lumped the injury assessment and the behavioral assessment together. And then about a decade and a half later, with a lot more science behind it, some of it directly pointed to from the 2007 one. These are such different issues. They were split out into two different papers, one in 2019 that just kind of updated and improved and expanded the injury criteria, and another one that re-evaluated the behavioral criteria, similarly, made this conclusion that, there's just not a single numerical threshold, and we should be, approaching these things with different ways, given the fact that they are probabilities, they are not thresholds, they're these context dependencies. And for behavior and masking, which are going to be the much more common things than these rare, high intensity events, we needed a different approach. Okay, next. Okay, and this is really my take on these couple things, but I hope it's useful, or at least it can trigger people's thoughts on it. But I think we should stop searching or expecting that we're going to get a simple single threshold for these really, more common things, especially for vessel noise, where injury is probably extremely unlikely. So for behavior and masking, we're just not going to get there. We've looked for 25 years. The science is telling us it doesn't exist. The kind of approaches, and Enrico Perrotta did a paper on blue whale behavioral response, where we took aspects of ambient noise to set some of the lower bounds, aspects of physical and of effects, auditory effects, to set some of the upper bounds, and then populated the middle of these with direct empirical measurements of response, exposure response for different contexts, and came up with these probability functions. I think that makes sense. We've done some work with risk assessment, taking these kind of probabilistic approaches and using space, time, and frequency spectrum overlap to get to sort of simpler, more transparent, understandable assessments that could allow you to kind of evaluate different scenarios. I think those make a little bit more sense than individual thresholds. But the last point I want to make on this is just the lack of having a single simple impact threshold that goes for behavior or masking across all species means that we need some of these kind of common sense frameworks for evaluating impact assessment, but it does not mean that we can't or shouldn't seek the kind of broader, simple, measurable target goals for URN that you're going to hear more about today, that people have set and established and evaluated, in many cases achieved. Okay, next. All right, just about through to passing over to Leela, but I got two historical slides. When you can, Julia. Okay, thanks. So like I said, the kind of formal in broad international engagement and progress on this is about 20 years old. There were two NOAA symposiums in the early to mid 2000s. The first one that just brought stakeholders together, and Roger Gentry and I were involved in putting that together, and Amy Scholich and I were involved in the one in 2007 that kind of went from, this is an issue we should consider and evaluate and learn from, quieting that the Navy has undergone and fisheries research vessels have undergone. So it wasn't the first time the issue had been addressed by any means, but just in terms of the broad international kind of engagement. And then there was a workshop that was very much in the game on sort of theme of multi-stakeholder, bringing people together, in Hamburg in 2008, that kind of led right into the work at IMO. And at that workshop, there were some broad notional aspirational goals and targets set for noise reduction, which I think set the stage for some of the work at the IMO. So that set off a series of informational papers and formally a proposal led by the U.S. at the IMO to formally address this issue. Next slide. Which led to a series of things in the way that the IMO works, building from getting on the agenda to initiating the development of some of the initial guidelines through MAPC, passed over to the Design and Engineering Subcommittee, and finalized these initial draft guidelines. And there's a lot of backstory on how that happened. I want to make sure I mention Kathy Metcalf's name from Chamber of Shipping of America. She was integral in that process, that early process, and has been involved with Game On and guiding us. So that led up to 2014, the guidance and guidelines for quieting ships, and that I think was an important step. But it became clear in the years after that the uptake of some of that for the initial guidance and the level of specificity that was in it could be improved upon, and that this would be an evolving process. And I think from the beginning, having multiple nations involved in the process was helpful. And things changed between different countries. And at the period after the IMO guidance came up, thankfully the Canadians really stepped up and picked this up at the IMO to look at why what the lack of uptake was, and plotted a course for taking this to the next level and seeing that uptake improve. So there was then some joint effort between Canada, the US, and Australia, submitting a proposal for further action at the IMO. And this is the point where I'm going to turn it over to Leela, who has been very centrally involved in this process from before then, but especially at this point. So I'll pass it to you, Leela, to pick up the story in 2021.
Thank you, Brandon. Yes, and we wanted to start this meeting reviewing the progression of URN work at the IMO to now really begin to highlight and bring awareness to the role that this organization is currently playing as a host for global information exchange. And as Brandon noted, Canada, US, Australia developed a proposal for the IMO to re-engage on URN in 2020. And with the COVID pandemic, this proposal was not considered until 2021. But at that time, it was adopted, sent to the Subcommittee on Ship Design and Construction, and that began the work to revise the existing guidelines. That subcommittee was successful in this work, and the revised guidelines came out of the Marine Environmental Protection Committee and went into effect on October 1st of 2023. SDC also proposed that the IMO gather information on the effectiveness and uptake of these newly revised guidelines during a 3-year proposed experience building phase. And the end of that year also saw the beginning of a 2-year global partnership program between the IMO and other UN organizations to support the building of capacity to reduce URN from vessels in lead pilot countries around the world, called the Glow Noise Project. And you'll hear more about that project later today. Then last year, this experience building phase and other actions that were considered to support URN work at the IMO were included in an action plan, which was also finalized by the Marine Environmental Protection Committee. And the IMO, responding to interests to extend the timeline for URN work at the IMO on its agenda until 2026 in order to collate this experience, noted that we would need further technical support, and the US and Canada provided that support. So this year, the Ship Design and Construction Subcommittee has convened an intersessional group to support the tasks of assessing the progress on this action plan and the collating of the lessons learned globally in applying the new guidelines to vessels. And all that progress will be reviewed in this coming January 2026, by that subcommittee, which has been asked to recommend back to the Marine Environmental Protection Committee as to whether more time is needed to gather that experience and how we're doing removing the barriers to uptake that has been experienced thus far for these voluntary measures. Next slide, Juliet. The revised guidelines seek to increase our engagement on URN reduction work around the world by presenting a sequential and yet cyclical approach. It's called noise management planning. And this chart highlights the steps in noise management planning, those taken on the left by ship owners, operators, designers, builders, manufacturers, and suppliers, and on the right by others, including maritime authorities or those with roles in URN reduction. The left chart notes that this process, this noise management process, engages all these parties the most effectively in early design stages for a new build, but that the process is also applicable to retrofits or for those considering operational or maintenance approaches to an existing vessel. The plan is organized around first measurement or prediction of baseline noise levels for an existing ship, followed by consideration of the target for URN that the vessel seeks to achieve. This target can be for a specific operational mode for the vessel. It can be relative to an existing underwater noise class notation. It can be a % reduction from that existing baseline, or it can be a specification associated with a marketed applied technical approach. But this target setting exercise is then followed by the identification of the URN reduction method that will achieve the chosen target. And these again can be technical innovations or operational approaches, speed reductions, other types of voyage planning approaches to how you operate the vessel, as well as maintenance approaches or a combination. These are then applied, followed by monitoring for the effectiveness of these choices. On the right, you'll see the roles of the other bodies that can be engaged in URN management planning as well, through the identification of areas and species that are sensitive to URN impacts, the interpretation of biological information that can be used to inform targets for reduction or maintenance of noise levels in an area of concern, the development of incentive programs for vessel users to reduce their noise in order to achieve targets, and again, the evaluation and monitoring that can note whether we have actually achieved those reductions, either by individual vessels in the region or collectively across vessel noise being contributed. Juliet, next slide. The guidelines therefore clearly articulate the role for setting targets and objectives within noise management planning implementation in order to support all stakeholders in evaluating their noise reduction progress. However, this planning process is noted, and this really does go along with what Brandon is talking about. It's noted to be cyclical, and it's meant to support all players in using the best available information and resources to take achievable steps, which they then evaluate the success of. They take in new information, and they adjust as necessary. Next slide. The guidelines include several appendices that summarize available international resources. They provide templates for management planning. Next slide. And in these templates, the information on establishing URN targets within noise management plans is further discussed, and the following points are made. Along the same lines we were just talking about, it is noted from the beginning that biologically based noise limits are likely to reflect cross-species and regional variability, and any universal limit is likely to serve as a summary of impact reduction interest across diverse environments. They further state that URN reduction targets for a given ship should consider the ship's purpose, its type, its initial prediction or baseline measurement, as well as operational considerations that they can be established associated with ship classes, tonnage, or other characteristics, that they can be adopted relative to class society sets of URN rules, that they can be gradually strengthened over a specified period as established by the ship owner, or they can be reduced as a percentage, they can be established as a percentage or relativistically to the initial baseline measurement. So all of this is talked about in the templates provided for going through the noise management planning process. Next slide. The action plan specifically calls for the sharing of information around target setting in two areas. First, associated with this experience building phase. And this is the first action in the action plan. Next slide. And specifically, in the further guidance for the experience building phase, global entities are asked to share their direct experiences setting targets for URN from vessels associated with implementing a noise management plan for a vessel or for a group. Next slide. Second, the action plan calls for shared lessons on the implementation of URN goal setting. And specifically, in the short term, actually, I think you need to click here. Can you click here? Yeah, one more time. Thank you. The action plan calls for shared lessons on the implementation of the short-term, first a short-term action, further commissioning of predictive studies to evaluate and project URN to inform target development, and then over the medium term, which would be by 2029, 6 years since the initiation of plan, to develop targets for vessels by type and by class, amongst other factors, and to be informed by the development of biologically relevant URN targets in regions and with indigenous knowledge incorporated. Next slide. So currently, an intersessional body at IMO is working to collate the short-term progress on these actions, the first 3 years, that experience building phase. And examples of the work submitted at the IMO include harmonization across class notations, centralization on of ship source level database data across around the world, comparison of increasing use of onboard sensors with in-water measurement systems, reports on URN reduction through technical innovation, so the actual achievement of URN reduction through different technical means, incentivization program development, and URN modeling, increasing URN modeling and predictive study. Next slide. It's been recognized that there's important overlap and synergy between work to increase energy efficiency of vessels and work to reduce their underwater noise. And the IMO has continued to create a platform for sharing advances in this space. And there's a second workshop on this topic to be held at IMO headquarters in London on November 6th to 7th of this coming fall. The co-benefits for air emission reduction goals, for cost savings or payback periods, for technological advances. These are important parts of the URN target setting discussion, and these themes are likely to come up several times in the presentations you'll hear today. Next slide. Likely you will hear both today and tomorrow about another very important IMO-supported space for growing momentum on this topic, and that's the Glow Noise Partnership. This project is working in collaboration with 7 lead pilot countries and 3 twinning countries to develop capacity to better apply the guidelines. And you'll hear about the opportunity this opens up for both leveraging the work that has been done around the world for the benefit of others, as well as better integrating and learning from the needs and priorities that countries around the world are facing in building quieter and operating quieter vessels. With that, I think I'll turn it over to you, Brandon, to close.
Yeah, just one very brief last set of possible next steps we've identified. We will circle back to these, and there will be more next steps identified, I know, over the next day of discussion and the panel discussion tomorrow. But the kind of next steps we've already identified as considerations collectively to accomplish, include a similar report on this quieting workshop. And I would encourage you to check out the previous workshops. There's recordings, there's detailed reports of some of the things that we've done. So there'll be a parallel effort to make the information and the products of the workshop the next 2 days available. There's already been an identification of a potential informational submission to either the Ship Design and Construction Subcommittee in support of the URN experience building phase, highlighting that the availability of the report and key findings of this workshop. So a follow-on from the products that are generated from this workshop. And, for us, honestly, and to think about, as Doug said, we're at the end of the third of these 3. What are the things that come next in the context of quieting efforts that Game On can accomplish and contribute to complementing other efforts that are happening. So this is just a starting point. Doug and I will pick up the kind of synthesis next steps at the end of the discussion tomorrow. So we'll come back to these points, and I'm sure other ones as well. So with that, I think, Juliet, we are through ours, and we'll turn it back to you to kind of coordinate the next kickoff of the first presentation group.
Great. Thank you so much, Brandon and Leela, for that very informative keynote presentation. With that, we are going to jump into session 2, which is focused on new insights on goal setting through the development and application of new measurements and prediction tools. We will get started with Vahid Vakili from the University of Southampton, and I will stop sharing screen so that he can share his, and we'll jump in with his presentation. Thank you.
Yep. Thank you, Juliet. Hello, everyone. It's a great pleasure for me to attend at this event. I'm sharing my screen. Yep. Can you see my screen now?
Yes, perfect.
Yeah. Hello, everyone. Thank you very much for the invitation. It's a great pleasure for me to be part of this time. Way of introduction, I'm Vahid Vakili, ex-captain of merchant vessels and a researcher at University of Southampton and champion of maritime decarbonization at Southampton Marine and Maritime Institute. Today I'm going to talk about underwater noise. And as we discussed, one of the target for reduction of underwater radiation noise, OCEANOS target, and we investigate about synergy which exists between improving energy efficiency and reduction of underwater noise and how it will be impact and comply with OCEANOS target. Shipping has been considered among the main reasons for increasing ambient noise in oceans. This graph plots ambient underwater radiated noise level within the ocean against here. Overall, this study concluded that globally from 1950 to 1980, ambient ocean noise levels rose by about 3 decibels per decade. Advocates of mandatory underwater radiation noise reductions have suggested that if remaining under-regulated, This trend is likely to continue, and for some regions, there is evidence to support this view. However, it is noteworthy that its trend isn't consistent globally. Some areas have shown stability or even a decrease in noise level. Moreover, there are disparities in projected underwater noise levels across different regions worldwide. These variations highlight the necessity to move beyond linear models and consider non-linear trends that encompass long-term cyclic dynamics. Achieving these necessitates at least 3 decades of uninterrupted monitoring to identify trends comparable to historical noise level increase observed in the Northeast Pacific. Some scientists have claimed that fuel efficiency measures, for example, speed reductions, could be contributing to such underwater radiated noise reductions, and others have suggested that natural phenomenon may be the cause. Considering the role of shipping and increasing the ambient noise in the oceans, the Okeanos Underwater Radiated Noise Target established a performance-based numerical benchmark for accepted levels of underwater radiated noise emitted by vessels under a specific condition. Its goal is to minimize the ecological impact of commercial shipping, particularly on noise-sensitive marine species like whales and dolphins. The objective was to reduce underwater noise pollution and protect marine biodiversity. Although it is not mandatory, the targets were intended to encourage ship owners and designers to adopt quieter technologies and build quieter vessels. The Okeanos Foundation for the Sea has proposed the following phase targeted to reduce underwater radiated noise in the low frequency band in order to reduce 3 decibel reduction within 10 years and 10 decibel reduction within 30 years. These reductions are based on historical trends showing a 3 decibel per decade increase in ambient underwater radiation noise, primarily in the eastern North Pacific between 1950s and 2000, driven by growing ship traffic and industrial activities. The initial goal is to flatten the curve and stop further increase, and the long-term goal is to achieve meaningful reductions below past peak levels. Accurate calculation of contribution of ships to local ambient noise level requires a detailed knowledge of shipping distributions, of long-range sound propagation, and of ships spectra, which is difficult to achieve and costly. Taking this into consideration, the Okeanos target to evaluate the contribution of the shipping industry within the ambient noise, we refer to reverberant room theory of ambient noise, Rowe's equation. It is a conceptual model used to describe how underwater radiation noise, especially from ships, contribute to ambient noise level in the ocean. There are some assumptions in this conceptual framework. Uniform distribution of sources. Ships or other noise sources are distributed randomly and uniformly over a large area. Homogeneous medium. The ocean is treated as a uniform acoustic environment, which is a very simplification assumption. Sound reflects and accumulates, like in a room, sound waves bounce and reverberates, and this creates a baseline noise level known as ambient noise. And a steady state condition. It assumes a long enough duration for the noise energy to reach a steady average level. The model estimates the contribution of population of ships to the ambient noise level at a given locations, helps quantify how the increase in global shipping, particularly with large, slow-moving commercial vessels, raise background noise over time, especially in low-frequency bands which overlap with whale communication. The ambient noise depends on 4 different factors, that is, average sound source level per ship, density of ship traffic, the attenuation factor, and water depth. It is assumed that the average sound source level per ship, in addition depth and attenuation factor, remain constant. We examine the shipping growth as a changeable factor and consider the fleet growth impacts in the ambient noise in deep ocean. However, it should be noted that newly built ships, through improved design, adoption energy efficiency measures, and greater attention to the underwater radiation noise footprints, are expected to be quieter than older vessels, thereby contributing to the reduction of ambient noise level in the ocean. We also consider that the number of vessels must not only be considered, and the transport work also should be taken into consideration. Referring to IMO's fourth greenhouse gas study, the transport work growth ranging from 40% to 100% from 2020 to 2050, translating to an average annual growth rate of approximately 1.2% to 2.3%. Considering the worst case scenario, by 2033, 26% increased surge in transport, which increased around 1 decibel the ambient noise. Considering the 3 decibel reduction per decade by Okeanos target, 4 decibel reduction in the source level per ship is required. By 2050, around 74% is surging in seaborne trade transport. It is approximately 2.4 decibel increase in ambient noise. And considering 10 decibel reduction by Okeanos target, 11.38 decibel reduction in the source level per ship is required. Taking this into consideration, we examine the relationship between IMO greenhouse gas strategy in reduction of underwater radiation noise, and if its regulation can affect in reduction of underwater noise from commercial vessels, and consequently the ambient noise or not, and evaluated if the meeting the Okeanos target with consideration of the IMO's greenhouse gas strategy achievable or not. Considering the aging global fleet and increasing stringent environmental regulation from International Maritime Organization, energy efficiency, particularly low-hanging fruit measures, plays a vital role in meeting the IMO's greenhouse gas reduction strategy, especially for existing vessels facing significant barriers to adopting alternative fuels. Given the technical, economic, and regulatory challenges associated with deployment of alternative fuel, especially for retrofitting the current fleet, it is anticipated that such fuel would not become widely available until 2040, with large-scale uptake expected only beyond 2045. In the interim, energy efficiency improvement offered the most immediate and impactful pathway to emission reduction. Studies estimated that energy efficiency measures can reduce emissions by up to 60% by 2030, translating to saving of 40 million tons of fuel, equivalent to 120 million tons of CO2. By 2050, the contribution of these measures, including speed reduction, is projected to account around 32% of total decarbonization potential. As illustrated in the graph, based on the feedback from 1,000 shipping companies, operational and technical efficiency measures such as speed reduction, hull cleaning, and voyage optimization are currently prioritized over alternative fuel for reducing greenhouse gas emissions for existing vessels. And the good news is that
remaining.
Yep. And the good news is that majority of energy efficiency measures have the potential to reduce underwater radiation noise from commercial vessels. Among the various available solutions, the adoption of energy-saving devices, air lubrication system, wind assisted propulsion system, electrification, and speed reduction and other operational measures has significant potential to both enhance energy efficiency and reduce underwater radiation noise. These measures are expected to play an increasingly important role in decarbonization of the shipping industry. And for instance, wind assisted propulsion can improve energy efficiency by 5% to 25% with even greater saving achievable when combined with other energy efficiency measures. In parallel, these technologies can also yield considerable acoustic benefits, reducing underwater radiation levels by up to 14 decibel and reducing the disturbance radius by approximately 28 kilometers. One illustrative case shows that one Case A vessel operating with 100 conventional propulsion generate the same underwater radiation noise impact as 25 Case B vessel using only 40% of wind propulsion system. Given the advantage and current market trajectories, it is anticipated that commercial vessels will become progressively quieter, thereby lessening their contribution to ocean ambient noise and helps to meet the Okeanos target. However, to fully realize these benefits, it's crucial to validate the performance under real-world condition during the experience build phase of any underwater radiation noise reduction framework. This should include comprehensive testing across a wide range of vessel types, size, and operating profiles, as most current data originates from laboratory studies and limited sea trials. So in conclusion, there exists synergy between improving energy efficiency and reduction of underwater radiation noise. It's predicted that the speed reduction, wind assisted propulsion system, energy saving devices, and air lubrication system play a crucial role in realizing the IMO greenhouse gas reduction strategy. The maritime sector transition toward electrification, fuel cell batteries, hybrid technologies can improve energy efficiency and also reducing underwater radiation noise. Low-hanging fruits, operational measures like hull and propel cleaning, optimizing vessel handling, passage planning can improve energy efficiency and also improve reduction of underwater radiation noise. The trend increasing the ambient noise of 3 decibel per decade is not consistent. In some area is plateau or even decrease, and even we have a discrepancy in some areas, and we have to take into consideration long-term cyclic dynamics in prediction of ambient noise. And by 2033, to achieve the target 3 decibel reduction by Okeanos target, 4 decibel reduction from source level is required, and it is 11 decibel per ship in source level by 2050. And considering the improving energy efficiency and contribution of energy efficiency for decarbonization, these targets is achievable. And we have to focus more on the deep sea for more precise prediction of underwater radiation noise on global scales. And the coastal enhancement effect needs to consideration when examining factors influencing ambient noise, and it amplifies underwater noise from coastal source, making them audible in deep ocean, as some of the vessels which are operating in the coastal has higher underwater radiation noise compared to deep sea ocean going vessels, and the ports play a crucial role in this regards. Underwater noise management plan for ports by considering technologies such as onshore power system and economic operational measures and policy measures, including a speed reduction and incentive program, play a crucial role in this regards. Thank you very much for your attention. If there is any question, I would be happy to answer.
Thank you so much, Vahid. We will keep questions for the Q&A session at the end of this first session.
Okay.
Next up is Vanessa Zobel. There I see her.
Hello.
Hello. Can you all see the screen?
I can.
Great.
Okay. Should I start?
Please go right ahead.
Okay. Hi, everyone. My name is Vanessa Zobel. I'm a researcher at Scripps Institution of Oceanography in the Scripps Machine Listening Lab with Caitlin Frazier, and I'll be talking about some of my work with some of the data sets we're working with right now. So you can click the next slide. Okay, so here is our sensor that we've had off of the Port of Los Angeles and the Port of Long Beach, the first and second busiest shipping ports in the Western Hemisphere, for about 20 years now. And you can see that the impacts of vessels really contribute to the acoustic environment, not just here, but globally all around the world. And in this environment in particular, it's shielded by some islands, so we can really see the effects of vessel URN in this region. In 2008, with the US economic recession, there was a big decrease in shipping. Ships were compiling their TEUs together, and there were less ships overall, and also the economy was down, so noise was way down. You can even see when the dock workers were on strikes with their labor negotiations, anchorage congestion that we had after COVID, the implementation of a queuing program, and in the future, we'll see what happens with noise with all the different things going on with the economy right now. But overall, you can see how ambient noise levels are really affected by vessel URN in these port areas. You can click next. So as Leela mentioned, we're operating in 2 regions for our source level databases. One is in the Santa Barbara Channel off of the Port of Los Angeles, and then we have 2 in the Gulf of Mexico that we worked up, one off of the port of Galveston, one off the port of southern Louisiana, and we're putting 2 more in June off of the port of Corpus Christi and the port of Tampa. So more source levels in the Gulf of Mexico to come. You can go next slide. Here's what we've gotten from these source level databases so far. We have tens of thousands of URN measurements, but people that that measure URN know that you have to be very picky at the ones you choose. So the usable transits are less than all the ones that we've measured. We have about 4,000 unique vessel types in each region. In the Southern California region, we have a good representation of cargo ships. About 80% of the usable transits are cargo ships. So we definitely got good representation from them in Southern California. In the Gulf of Mexico, there's a really good representation of tankers, which we do not have from our Southern California database. So that's super helpful. And those tankers are going a wide variety of operations. So a lot of data there that is helpful to kind of make more models that are representing more ship types going more operations. So as I mentioned, we're putting 2 more sensors out in shipping lanes in the Gulf of Mexico. So hopefully expanding the Gulf of Mexico URN database as well. Go next slide. So a couple different URN reduction techniques that we've been studying so far. We have partnered with the Blue Whales and Blue Skies program that's operating in California they've been doing this program for 10 years at this point. It's completely voluntary. This is not regulated at all on the California coast, and they have really good participation. So it's awesome to see what you can do with just voluntary incentive-based programs. Next click. These are anonymized carrying companies that are participating in the Blue Whales, Blue Skies program. So over the years, they have reduced their speeds, and I hope I don't have to convince anyone here that at least at the population level, reducing speeds very much reduces URN. You get about, at this site, a 1 dB per knot reduction in speed over ground versus source level. This is the 63 hertz source level here. So these are 6 of the biggest shipping companies in the world that are participating, and it's really great to have their participation in this program. And this program has now spread to the entire or much of the California coast off of San Francisco and Monterey Bay as well. So much of it is covered. These vessels are reducing their speeds. We just had the award ceremony where we got to give the companies that were participating a trophy, and they really appreciate the recognition. So this is an incentive program that's doing really well for the California coast. Next slide. Oh, decrease speed, decrease URN. Yes. Okay, so another method of URN reduction is design. We did a study in 2023 partnering with one of the biggest shipping companies in the world, Maersk, to study how one of their retrofitting initiatives may or may not have reduced underwater radiated noise. The retrofit was for fuel efficiency, but because of the retrofit or because of the new design of the propellers and the bow, we wanted to see if that also may have reduced URN. Next click. We found that URN was reduced for these sister ships in the low frequencies below 100 hertz. So we think that this helped in reducing cavitation at the propellers. But in the higher frequencies above 100 hertz, there was no decrease. So this is just one example of a design initiative that we looked into, but next slide. And you can click like 3 times. Thank you. One more time. Okay, good. There have been so many retrofits that have happened that the vessels are already in the water passing our sensor from Maersk, CMA, CGM, and other shipping companies. So it'll be really interesting to see how different retrofitting efforts and different designs are helping URN reduction. And we don't have to wait for new ships to be built. These are already in the water. So, and new vessels like the new Maersk methanol powered vessel is also in the water. So we can start teasing out how these different designs are reducing URN. Okay, next slide. Okay, so how do we know when we're done? Or are we ever going to be done? And that's how we're going to start talking about target setting. And so you can click again. Thank you so much. So I'm just starting to think about this, and this is just an example of URN targets for 4 size classes. This is just for container ships. So here's the 10th percent, or the mean and the 10th percentile URN across these different frequencies as the target. And it's really interesting to see the spread of these different size classes and the speeds that they're operating in. The smaller vessels are going at faster speeds. It's interesting to see. So even if one of these vessels is transiting at 10 knots and they're well above the target, what design are they? What vessel design is that? And can we make sure that if a vessel's transiting at, say, 12 knots and is already at the 10th percentile target, can we incorporate those designs into the new builds or into the retrofitting efforts going forward, so that we can make sure that information is used as a spec in new vessel designs moving forward? Okay, next slide. Okay, so Brandon touched on this, but it's super important to also think about the space and time for URN reduction. So spatially mapping URN in different biologically important areas. This is the Southern California area, which encompasses the Channel Islands National Marine Sanctuary and blue whale and humpback whale biological important areas. You can go to the next slide. So how does speed reduction affect these areas and reducing sound levels in these areas? And is it enough? You can go to the next slide.
Also, you have 1 minute remaining.
Yes, yes. Okay, so I know some folks have been studying the level of onset of biological adverse effects, or LOB, which is something I'm super interested in for this region, and thinking about if we can't get to that threshold for all these variety of animals via speed, what are the other options? Is routing an option? Is, new designs an option, or a queuing system? There's so many different options. So figuring out what is available for this region for the different thresholds and targets in terms of the biologically relevant thresholds. And I'm glad Brandon mentioned that, like, picking a specific target or threshold for a specific species is really difficult, and what might be the threshold for a blue whale versus a fin whale versus a humpback whale versus a fish might all be different. So but regardless, the noise needs to come down. So figuring out both the targets on the vessel sides of things and how it's biologically relevant to the animals that we're trying to protect is kind of coming at it from both sides is super important. So next slide. I think that's it. Okay, thank you so much. These data sets have so much work going into them, so many different people, our technicians, our engineers, our interns, our fearless leaders like Kate Frazier. So thank you so much to everyone that's been a part of it. There's been hundreds of people at this point that have been on ships servicing these instruments. So thank you so much to them, and happy to answer questions at the end of the discussion.
Thank you so much, Vanessa. Appreciate your presentation. Next up, we have David Hannay from JASCO.
Yes, thanks very much, Juliet. And I don't see my slides yet, but
putting them up right now.
Okay. Thanks. Great. Yeah, thanks. Very happy to be here today, and nice to see so many people that I've worked with for many years on the call today. So I will just get into it. The talk today is on developing systematic approaches for characterizing and rating ship underwater radiated noise. And I should introduce myself, David Haney with JASCO Applied Sciences. I'm a senior scientist here, and I'll be talking about some of the collaborative work we've been doing for the past decade. So we'll go to the next slide, please. Yeah, so I and my colleagues at JASCO have been working closely over the last decade, as I say, with several organizations, primarily recently the Vancouver Fraser Port Authority's ECHO program. That's the Enhancing Cetacean Habitat Observation Program. And also Transport Canada, which is the Canadian government's transportation management agency. And they are also responsible for managing marine traffic. Also with ship classification societies, ship owners, and the standards community primarily, and as I say, over the last 10 years or so, to develop approaches for characterizing ship URN, and also for moving towards developing rating systems for ship URN. So this slide just shows some of the progression over the last 10 years of the work we've been doing with all of these organizations. In 2015, we deployed the first cabled underwater listening station for making measurements of vessels, commercial vessels on their regular shipping routes. A large number of measurements have been collected to date, very similar to what you've just heard from Vanessa talking about the Scripps measurements. We've done other measurements with deploying different configurations of hydrophones to determine optimal ways to measure ship noise, and that work has contributed to developing standards, primarily the new ISO standard 17208-3, which is in draft right now, but that's a really key shallow water measurement standard. From the measurements, we've been developing models, radiated noise level and source level models, primarily, doing multivariate analysis on the measurements to look at things like this noise savings from reducing speeds of ships, and papers have been developed and published on that. Working on acoustic propagation model improvements, so trying to take the source level models and put them into propagation models to estimate the footprints of ships in the ocean. And those are real-time models. So our TMIA is our real-time model. And I should just back up and say ECHO and Piano are the two most recent radiated noise level and source level models that have been developed with some of these measurements. From 2018 to 25, we've been doing many modeling studies using all those models to predict noise levels for different scenarios for shipping. And these models also fed into some European projects, the Saturn project and the Navison project, that I'll talk about briefly. And then most recently, for the last 5 years, working with different organizations on developing targets. And some of that work has been class societies, ship class societies. ECHO's developed a noise rating program, and most recently, I'll be talking about the UVNERT, which is Underwater Vessel Noise Reduction Targets project with Transport Canada. Next, please. So as Vanessa was talking about the studies with Scripps, we've been doing studies with the ECHO program and Transport Canada, deploying underwater listening stations. This is the Boundary Pass station. It has 2 frames of hydrophones that are deployed on the seafloor. And these are nice locations because they're in narrow shipping lanes where the shipping lanes are adjacent to each other. So the ships are at fairly close distances, typically from overhead to about 700 meters horizontally. And the depths are close to 200 meters. So it's a very good environment for getting large numbers of ship measurements. We also measure the ocean current, so we can correct for the speed over ground that comes from AIS to calculate speed through water, which is a more important parameter. And this system to date has collected about 70,000 single pass measurements of about 10,000 ships. And these have been at different speeds, different drafts, and all of that information is recorded in what's known as the ECHO Transport Canada database. Next. Talking quickly about ship model developments. So we've got all these source level and radiated noise level measurements. We've used that with others to develop source level models, and a collaborative two primary models have been developed. The Jomopan's ECHO model was developed in 2021. That was based on multivariate analyses of all of these, the data and the metadata, the speed draft, for example. And then more recently, the piano model has been developed in a collaboration with Mirren, and that model looks at some more details such as propeller type and number of blades of propellers. So it's a more sophisticated, fine detail type source level model. Next. Now, these source models are good for knowing the noise emissions of ships, but we also want to know what is the footprint, what is the insonification of the ocean develop. So that's where exposure models are required, and Artemia is the one that we've been working on for the last few years. This model is also useful for looking at assessing scenarios such as slowing ships, rerouting ships, developing no-go zones, doing time limits where ships may be not allowed at certain times, convoying ships, etc. And so we've been doing lots of studies with Transport Canada for looking at ways that they could reduce exposures to key habitat for marine mammals. Sorry, I think we went back one. Could go forward again. Yes, there we are. And so the other thing these models can be used for is looking at, so the Navison project, for example, did that through, it looked at levels projected into the future as well, based on expected changes in ship traffic. So I think we're going back again.
Sorry about that.
No worries. And then a more recent project was to look, Transport Canada and the ECHO program, Vancouver Fraser Port Authority, we're interested in knowing what's the distribution of energy by different categories of ships. For example, what's the fraction of energy by ferries, container ships, bulk carriers, and fishing vessels. And one of the interesting outcomes of that study was that fishing vessels in some areas produced a large fraction of the noise energy. And that wasn't because the ships themselves produce much energy because they're much lower source level, but they loiter in certain areas for long times. So they actually contribute to a lot, which is a surprise. So the models are really useful for understanding what may be driving the exposure of a given location. Next. There we are. So now getting to all of the work has sort of been getting towards developing URN targets. And when I say targets, these are targets for the noise emissions of ships, as opposed to targets for sound levels in the ocean. And what if we can get the ship's source levels reduced, that will automatically have a benefit to the environment. So this is where our focus has been. So starting off, in 2019, we developed a rating system that was based on the frequency weighted radiated noise level. And the frequency weightings used are the functional weighting systems that Brandon discussed in the first talk. These are published by NOAA. And so what we did was, on the right figure you see, for every measurement we develop a rating. And at the bottom, we create those sort of heat bars that you might see on the energy used by your dryer or washer. So we rate the vessels relative to all other vessels in the same category. So for example, a bulk carrier would only be rated against other bulk carriers. Further, we do scaling to look at the size of the ship within its category. Next. So the next piece of work we did was a collaborative study with many ship classification societies. In fact, all of the logos on the right represent class societies. I see Eric Baudin's going to be talking in about half hour about some of their work, but they were one of the collaborators here. And the idea here was to try to align the approaches these class societies use to develop quiet notations for ships. Now, what the problem had been was that each society had used its own measurement approach, and the overall goal was really to try to align these societies to use similar, at least, measurement approaches, so that their measurements could be comparable to each other or to other societies' measurements. And the final goal was really to get everybody to use standards. And with the development of ISO 17208-3 and -1, that really does help provide a sort of a consistent approach. And that's sort of what the outcome of that study led to. Next.
We also have about 1 minute left.
Okay, let's quickly go through these. So Transport Canada in 2022 and 23 developed the UVNERT project, underwater noise reduction targets, and they initially developed a set of simple limits, noise limits, and these are noise limit on the vertical axis and frequency on the horizontal here. And so each category of vessel was assigned to one of these limits. It was a fairly simple approach. Next. Yeah, so just last year, we took a closer look at those limits and compared them with the ECHO database measurements, and we modified the limits. So we broke them into two categories, sort of merchant ships on the top, and the merchant ships have a hump in their noise spectrum just below 100 hertz, and non-merchant ships, which would be ferry, fishing, and passenger and tugs. We also developed actual limits based on the quartile levels of different ships. So, for example, we can divide container ships into 4 quartiles, and the limits are useful for doing that. So these are the most recent UVNERT limits. Next. Oh, sorry. Well, anyway, I think the last bullet on the last slide was missing, but we're doing a pilot project, or involved in a pilot project right now with shipping companies to test those limits, and so that work is underway as right now. And I believe Orly Kosandi-Godin from Transport Canada will be talking more about that. So really, just to summarize, we've developed this in collaboration with ECHO and Transport Canada, this ship URN data set. And just so you know, an anonymized version of this data set is now ready to be released, so people can get their hands on this really amazing data set with lots of metadata included. We have the URN source models and exposure models. The work has supported the development of standards, especially 17208-3, and the recommendations have been made with the aligning classification societies, which we'll hear more about. And we've developed 2 approaches for defining ship URN targets. And as I say, the pilot project's underway to test those. So that's it. Thanks.
Thank you so much, David. Appreciate that great presentation. And we look forward to having questions put in the Q&A so that you can all ask him more questions. Next up, we have Rachel Arison from Maritime Blue. I'll get your slides up.
Hi, thanks.
Okay, there they are.
All right, great, awesome. Okay, well, we are gonna move from the global to the local here. And what I'm going to talk about is how do you take the research on vessel underwater radiated noise and marine mammal impacts and turn it into a regionally supported vessel quieting intervention for a very specific purpose. If you can go to the next slide, please. So Quiet Sound is a program at a larger NGO, Washington Maritime Blue. These are our funders in our current fiscal year. Thank you to all of them for supporting our work here. Next slide, please. And I'm here in the Pacific Northwest. I'm in Seattle, and I'm very pleased that we have several tribal partners in our coalition because Native peoples and whales have shared these waters since time immemorial and still have a very active role in managing their usual and accustomed fishing areas today. So I want to thank the Makah tribe and the Northwest Indian Fisheries Commission in particular for their role in Quiet Sound. Can you go to the next slide? Thanks. All right, so what are we? We're based in Washington State. We are a non-regulatory coalition, so our programs are voluntary. We are not a regulatory agency. And the benefit of that is that it's let us move pretty quickly in putting targeted programs into the water to benefit the southern resident killer whales. We really focus specifically on disturbance from large commercial vessels, southern resident killer whales. Those vessels, those whales in Washington State. And I think you will hear a little bit from the ECHO program as well today, which has a very similar program just north of the border in BC. Next slide, please. So if you're not familiar with southern resident killer whales, there's only about 74 remaining, plus or minus a baby or two. And they've got three major threats that were identified by the Orca Task Force in 2018. That's prey availability. They primarily eat salmon, and they primarily prefer to eat Chinook salmon, which are also endangered. Water quality and vessels. And the vessel bucket includes both the underwater noise, just the presence of vessels, and strike risk. So Quiet Sound formed in 2021. Next slide. We formed two groups. We've got a leadership committee, which is our consensus-seeking decision-making group that sets the strategic direction of the program. And that includes state and federal agencies, tribal governments, ports, conservation NGOs, and the maritime industry, all sitting around the same table. And they're supported by a very diverse advisory group that we call the ORCAs. And that advisory group includes lots of different types of people on the water, representing different vessel types and different operational schemes, as well as Orca experts and acousticians. Next slide, please. Our strategic focus areas include operational measures and detection alerts and supporting vessel quieting, but I'm going to focus on the operational measures. This was the first focus of our coalition when we started in 2021, because we knew we needed to quiet the current fleet, and the whales can't wait for the quieter future vessels. Next slide. So in the Pacific Northwest, if you're not familiar, we've got this nice, small, cozy waterway called the Salish Sea. And once you get into the Salish Sea, you've got vessels sharing pretty confined waterways with the critical habitat of the southern residents. Next slide. The vessel noise can mask their vocalizations and their echolocation. So they're acoustic specialists. They need an acoustic habitat to hunt, find their food, socialize, and use less energy to communicate with each other because they're social creatures. Next slide, please. As Dr. Vakili shared, speed reduction is one of the most effective interventions for URN reduction, and it's effectively free. So we know that other operational measures in this area were not as feasible, so we turned our attention to a VSR. Next slide. This is from Dr. Chloe Malinka. So when vessels slow down, they get quieter, and that gives the whales more acoustic habitat where they can find fish and succeed in foraging. We know that there's research that has been done to show that about a 50% reduction in underwater noise in combination with an increase in the availability of prey would support the recovery target for these whales. But also, as Dr. Zobel said, we just know the noise needs to come down. So next slide. How do you take this sort of concept of noise coming down and turn into a program on the water for vessels? We worked with maritime stakeholders to develop this regionally supported slowdown area, modeled on the Echo slowdown in BC. It's about 20 nautical miles of habitat at a time of year when primarily the vessels in this area are the large commercial vessels. So winter in the Puget Sound, not a ton of recreational vessels. So we knew we'd make a big noise impact with this slowdown. And these speed targets represent a reduction in speed of about 30% from usual operating speeds in this area. Next slide, please. We committed to adaptively managing this program over time. So every year we've made a little tweak to the program, trying to find the solutions that are the most impactful for the whales, safe for the maritime industry, feasible for the maritime economy, and minimally impactful on maritime trade. So we've done this for 3 seasons now, and each year we've made some small improvements. Most recently, we've added a dynamic starts. We start when the whales are confirmed to be present in this part of their habitat. And we most recently added a speed target for tugs. Though they go slow, they can go even slower. Next slide, please. All right, so what are we seeing out there in this voluntary world? So of all traffic going through the area, we see about 66% to 71% voluntarily participate in this slowdown. And we get this data from the Puget Sound pilots, the professional pilots on board. We also look at speed through AIS data and a tidal model in partnership with SMRU, our science consultants. And these 2 participation metrics, I think of them as a vessel that wants to slow down and succeeds in partially slowing down, and the vessels that get all the way down to our speed target levels. So all those participating transits contribute to noise reduction, and the ones that get all the way to the target levels, the most. Our slowdowns get a little longer every year because the whales are continuing to use this habitat a little bit more every year, as we see in their usage data. This most recent season, they were present for over 50% of the slowdown. So, better than a coin toss chance that you're sharing the water with an endangered whale. And we had vessels slowing down to do that. We're still calculating the noise reduction for this season, but we know last season we reduced underwater noise by 3 decibels. You can go to the next slide. It's good. And that's a 50% reduction in noise intensity. SMRU also calculated for us quiet time. So there was a NOAA study that showed that, NOAA and UW, I think, when noise is over 110 decibels, southern residents are incredibly unlikely to succeed in hunting salmon or fish. So we had over an hour every day of time under that threshold, where theoretically the whales have more foraging success. So it's no impacts to maritime safety, minimal impacts to maritime trade, and effective for the whales. That was a lot of words. And I didn't even get to our work on setting up thermal cameras to detect whales in the dark and the other neat stuff we're doing. That QR code does not take you to a virus. It takes you to our newsletter, where you can sign up for updates from Quiet Sound as we release reports and updates about our programs. And my email is not on here, but it's rachel@maritimeblue.org, and I can put that in the chat. Thank you all so much.
Thank you so much, Rachel, for that great presentation. Appreciate that. Folks, please write your questions in the Q&A for Rachel and the other presenters. Next up, we have Orla Robinson from Vancouver Fraser Port Authority. And Orla, if you are able to put on your camera, I can spotlight you and I will share your presentation.
I think I have my camera on. Can you see me now?
I cannot see you, but I can spotlight you. Perhaps try to turn your camera on one more time.
Weird. My
oh, there you are.
Okay,
yes.
Sorry. Yeah, Teams gave me a weird message.
No worries.
Morning, everyone. Thanks, Juliet. Yeah, my name is Orla Robinson. I'm an advisor to the ECHO program. Dave and Rachel have done a great job of introducing some of the work that the ECHO program has been doing over the last number of years. And I'm just going to focus this talk on some of the work that we've been doing more recently around the concept of developing regional noise targets for the shipping sector. So next slide, please. So very briefly, the ECHO program was convened in 2014 with very similar remit to what Rachel just noted, focusing on reducing the impacts of shipping on at-risk whales, specifically the southern residents in southern BC. And so Rachel showed a map of critical habitat in her presentation. This map also shows both the critical habitat on the US side as well as on the Canadian side, as well as the international shipping lanes shown in blue, where vessels transit through on their way to Vancouver, which is shown with the star. So as Rachel noted, critical habitat is legally designated on both the Canadian and US side, and underwater noise is a key threat impeding the recovery of the species. Next slide, please. Since 2019, the ECHO program's work has been largely driven by a Species at Risk Act conservation agreement, which the Port Authority and a number of the other marine transportation industry partners entered into with the Government of Canada to reduce acoustic disturbance and support the recovery of the southern residents. And the language of one of the strategic priorities in that conservation agreement, which spanned from the original 2019 agreement to one that was newly renewed in 2024, speaks to the ECHO program's role, which was to convene a task group to help facilitate a conversation around developing regional noise targets or other noise management approaches for the shipping sector. And of course, the context for this is the imminent threat status of the southern residents and their low population level, and the fact that a number of development projects have also been approved in Canada over the last number of years, and vessel traffic numbers are anticipated to increase imminently with a project that came online in 2024. And the fact that there is no existing formal framework for managing cumulative noise in the region. Next slide, please. So in early 2023, an invite was shared with all of our ECHO Advisory Working Group members, which also has a wide membership. I think it was shown in the first slide, but working with marine transportation industry, government, Indigenous communities, and environmental NGOs. But we did also include the invite, or extend the invite, to some technical experts, some of whom are participating today and tomorrow. So we have about 20 representatives right now in the task group from Canada, US, and Europe. We've had 5 workshops and meetings to date, as well as communications in between, really just to get clarity on the objectives of the process, a preferred target setting approach, and next steps. And so I'll just walk you through some of the work that we've managed to advance so far in the next few slides. So next slide, please. So some of the key questions we kind of started with underlying this process are, how can we best monitor changes in noise over time? How do we best understand how those changes in noise might affect the southern residents? And also how changes in noise over time are going to impact the effectiveness of some of the voluntary noise reduction measures that we already have in place. So Rachel spoke to her slowdown work, which has been underway on the US side, and the ECHO program has been implementing seasonal slowdowns since 2017 in a number of different sort of sub-regions through critical habitat on the Canadian side. And so one of the other, pieces of feedback in our early workshops was that given that funding and resource availability to all of us is not infinite, we also heard a desire to take a more pragmatic, adaptive approach that builds off some of the existing work, much of which Dave Hannay spoke to or touched on, whilst also maintaining awareness of other relevant work taking place elsewhere in the world, so that we can help advance the target development process in the most efficient way possible. Next slide, please. So in our first workshop, we evaluate, and a couple of workshops, we evaluate a range of potential target setting approaches for consideration, including examples from many places in the world where they're available. And the approaches in general related to either setting a target around a vessel, the vessel itself, or around the animals or the species, and typically through the use of coarse or fine scale models. Through our discussions, where we kind of landed at the end of our second workshop was a bit of a hybrid approach, which was to advance the concept of developing a vessel-based noise accumulation target that is biologically relevant. So that was selected as the preferred approach that should be further explored. Next slide, please. So this preferred approach, the vessel-based noise accumulation approach, involves the use of a coarse scale regional model, which, as Dave noted, has already been developed by JASCO. And so that model uses the source levels of those 70,000 measurements that have been collected by the ECHO program and transport over the last 8 years. It combines those with AIS data to generate a noise level at a range of different frequencies in each cell of the 800-meter model grid. And in terms of setting a target, you can decide if you want to accumulate noise on a monthly or an annual basis. You can decide if the target should be set in a specific region or sub-region. And it would all be relative to a reference period or a target period. So as an example, you might say the annual target for sub-region X should not exceed the accumulated noise of reference period Y. So once that reference period has been selected, you would then track noise contributions from a future year against that period, while of course also giving consideration to how those changes in noise levels are relevant to the southern resident killer whales, as well as which vessel sectors are contributing to noise where, as Dave mentioned, so that mitigation efforts can be targeted to specific subregions if necessary. So in terms of making the target setting approach biologically relevant, the first sort of easiest step, I guess, would be to set targets in the southern resident high use areas and using frequencies that are relevant to the southern residents. But there are also a number of potential other animal-based bioacoustic metrics that we explored, which could be evaluated in parallel to evaluate biological relevance. Next slide, please. So to, I guess, address the question of how changing vessel traffic might impact the effectiveness of existing noise reduction measures and slowdowns, etc., as well as the animals themselves. In 2024, we did commission JASCO to advance a fine-scaled model-based study in a smaller subregion focused on SRKW high occurrence, so southern resident high occurrence and core habitat area, which is shown in pink and blue, as defined by Fisheries and Oceans Canada, DFO, which is the kind of NOAA equivalent in Canada. And this area, this subregion also overlaps with the ECHO program voluntary seasonal slowdown initiatives in the Harrow Strait and Boundary Pass area. So the first phase of the study involved acoustic modeling of sound levels associated with 8 possible present and future vessel traffic scenarios. The second phase evaluated present and future traffic scenarios, the same 8 scenarios, using 4 animal-based metrics. Next slide, please.
We also have 1 minute remaining.
Okie doke. So I'm not going to get into a lot of detail of the text on this slide, other than to say, in the absence of the magic number that Brandon spoke about, the elusive magic number, single threshold for southern residents earlier, these 4 bioacoustic metrics were selected and deemed to be biologically relevant to the southern residents by task group members, as well as some additional invited experts from DFO and NOAA. The metrics were selected, with evaluating changes in communication space, echolocation space, quiet time, broadband noise in mind. And I guess that the overarching kind of findings and discussions that we had with the task group was that this multi-metric approach allows you to evaluate a range of effects to the animals in space and time. Some metrics are more driven by the amplitude of noise output, some are more driven by the duration of vessels in a region or a subregion, and some by the frequency range. And so the task group kind of advised at the end of that evaluation that it would be good to keep the balance of using multiple metrics in our evaluations as we move forward in the absence of that kind of single threshold. Next slide, please. And so I will just say that earlier this year, the Canadian government announced that they are working on a process to identify interim underwater noise objectives within southern resident critical habitat. Due to the recent election cycle in Canada, conversations have been a little bit on pause. So we're still waiting some clarity from DFO on their plans before we proceed further with this process, just to make sure we're kind of all aligned. But our next workshop ideally will focus on selecting what that reference period or target period is, and in identifying roles and responsibilities to kind of move forward the tasks that are needed to advance this further development of this target setting approach. So we've made pretty good progress, I think, to date on collectively defining what might be done. There's definitely more work to be done in terms of defining how we're going to do it and who's going to do the remaining stages of the work. But I'll stop there, and I'm happy to take any questions in the question period or by email afterwards.
Thank you so much, Orla. That was incredibly interesting, and agreed. Please put your questions into the Q&A because we have that coming up shortly, right after Eric Bowden's presentation, which Eric is with Bureau Veritas or Veritas, and he will present now. I'm going to share screen. Sorry, Eric, I need to pull up your presentation. My bad. Oh, actually, do we have Chris first? Unless, Eric, you're on, would you like to go and then Chris?
You hear me?
I can hear you, yes.
Okay, but I cannot see the slides yet.
Yes, one moment, please.
So meanwhile, may I introduce myself? So I'm working with BV, Bureau Veritas, a class society, as an innovation and energy transition manager. And I'm very thankful to BOEM to invite me for sharing with you what support to ship owners engagement towards URN related action is ready to be brought. So it's not as comprehensive as all the solution existing, but a few elements out of recent projects. So next slide, please. So first of all, a quick regulatory outlook. Over the past 10 years, there has been a growing concern about underwater noise pollution from ships, and this has led to the acceleration of regulatory frameworks at the international, European, and national levels. I do a focus on Europe because I'm French and concerned by European directives, as you could have guessed. As highlighted in the slide, some key development include UNCLOS, Barcelona Convention, IMO PSSAs, which have established the foundations for addressing pollutions as a whole, pollutions to the ocean, and so implicitly, in principle, include underwater noise. But I have also listed international conventions such as ACOBAMS, HELCOM, and OSPAR, which have quite recently stated explicitly commitments for their member states to address and reduce underwater noise within the next 5 years. So this is a big change. With regards to standards, I have included the main ones, so the ISO 17208 series, and also, no, the previous slide, please. Also the IEC standards. With regards to class societies, it has been said already, 8 of us have provided rules of regarding URN measurements to date. And what I like you to retain today as the picture of the day is the prime importance of, the next slide, please, of the IMO guidelines and the related experience building phase that has been launched for 3 years since October 2003. Additionally, the ISO 17208-3 dealing with underwater noise measurement in shallow waters is about to be finalized, and within the
Oh, Eric, your camera just went away. Oh, but you're back. You're back. Go ahead.
I hope it's not the bandwidth, but okay. So the lobe threshold-like approach has been established to start guiding the member states, or European member states, to implement the Marine Strategy Framework Directive and to evaluate and further maintain what has been called the good environmental status of their waters with regards to underwater noise. Next slide, please. So focusing a bit more on the IMO experience building phase, the key steps for ship owners during that phase are establish a baseline of the vessels with regards to underwater noise, set the ambitions and targets for noise reduction, develop and implement reduction strategy, and monitor, evaluate the effectiveness of the measures taken. Is it sufficient to facilitate the engagement of ship owners? That's my question today. So next slide, please. All this framework is non-mandatory, and with a non-mandatory framework such as these guidelines, we clearly need incentives, and that has been explicitly included in the guidelines text as a cornerstone of its successful implementation. Next one, please. We have developed within a NICI-funded project, PIACO, a fully dedicated index, the Noise Ship Index, fully dedicated to underwater noise. This NSI is structured around 4 pillars addressed to a single ship. And the aim is to facilitate the efforts and to reward the effort of the ship owners alongside these pillars, which are management and empowerment, diagnosis, reduction, and achievement. These pillars are supported by 19 criteria, allowing ship owners to be scored on their various efforts toward addressing exclusively underwater noise actions. Next one, please. The NSI provides 6 levels of ratings to account for the comprehensiveness, complementarity, and the importance of the efforts performed by ship owners. It starts with the iron level, where the ship owner has basically brought evidence of its consideration of URN, and it ends with diamond level, where the vessel under evaluation has effectively achieved the compliance with ICS 209 limits. The intermediate steps are taken alongside the baselining of the ship, the solutions studied to improve it, and their implementation up to an effective confirmed URN improvement, either relatively to the baseline or with compliance to given limits. Next slide, please. You remember that the baseline itself is the first pillar of the IMO guidelines corresponding URN action plan. Another outcome of the PIACO project is the Smart URN, a turnkey permanent station that can measure underwater noise of individual vessels in real time and 24/7. And this station is compliant in terms of instrumentation, data quality, and data processing with the class societies, and especially the recommendation 181 from IACS. So this station clearly helps to incentivize the baseline establishment by providing transparent and cost-efficient measurements at the usual cost of single-shot class measurement has been divided by a factor 6 with this solution. But also reliable data and trustworthy results, because although we are not in the fully aligned with class condition, because, for instance, the ship passes by the buoy but is not forced to make several transects as the class is required, but we have the same instrumentation, and so the same data quality check and data processing are applied and considered, giving confidence to the results. Next slide, please. During the PIACO project, a bit less than 700 individual vessels have been validated and stored. And for each of these ships, the corresponding baseline measurement report can be requested online. It provides detailed information on the vessel's underwater noise level, including source levels in 1/3 octave band, comparison with class limits, comparison with other URN measurement in the database, and individualized advice and comments. So in conclusion, with the next slide, please, what you need to remember, to consider and reduce is in fact nicely summarized by the IMO guidelines and URN action plan main steps. Understand what is at stake with regards to your ships, where and how they operate with regards to URN related issues, be aware of the last regulations, baseline your assets, lay down your ambitions, choose, test, and implement solutions, and measure their effectiveness. So we have enhanced now methodologies and appropriate tools. And when all constraints are considered, because stakeholders are engaged, and that's what we have done with all you guys since 2014, then we do move efficiently towards success. So let's go and let's shape together a better maritime world, because as Robert Swan, a famous polar explorer, wrote, the greatest threat to our planet is the belief that someone else will save it. So let's go together. Thank you.
Merci beaucoup, Eric, and appreciate that great and succinct presentation. Last but not least, for session 1, we have Chris Waddington. And please add your questions into the chat, and I will share Chris's presentation.
Julia, I think Chris is actually
into the Q&A.
too.
Oh,
And
he's
we're
in
into
session
Q&A.
2.
Yep.
Great, perfect. Thank you
Q&A.
for keeping me on track. For those who presented during session 1, if you are able to turn your cameras back on, and we will jump into Q&A. Wonderful. Well, thank you so much all for your presentations. There were some great themes that came up regarding barriers to uptake, threading in Indigenous knowledge, the impacts of economic downturn or recessions, perhaps even positive impacts, the changes in how collaboration can be valuable, and the value of different voluntary opportunities, and the value of, again, collaboration across not only the private sector or the public sector, but collaboration in a multi-sectoral way. There are several questions, some clarifying, some more thematic in the group chat, in the Q&A. I will not get to all of them, but some that we can start off with. Rachel, you spoke about the benefit of multi-sectoral collaboration. I was wondering if you could elaborate a little bit about that.
Sure. We have found that when we first started Quiet Sound, we thought that it would be best to have separate work groups for kind of each sector. So just for mariners, just for orca experts, just for operators of passenger ferries, for example. But over time, what we found is that all these folks want to hear from each other. Even in this fairly small world, there were already silos. So bringing folks together in this collaborative space has been really beneficial to our coalition. And there's some folks at the table who haven't traditionally worked together, or perhaps have traditionally been opposed to each other in other spaces, but have been able to come to consensus on we need to reduce vessel impacts on southern resident killer whales. So I would encourage anyone undertaking one of these types of initiatives to really focus on the structure and the people you bring together, because taking the time to really build consensus has let us move more quickly.
Great, thank you. Dave, perhaps a question that is more logistical, but your data is so valuable, and the group is wondering if it's available to the public. Specifically, your anonymized data set.
Yes, anonymized data set. So one of the guiding principles of the ECHO program and Transport Canada programs is that the collaboration with ship owners requires that we don't want to hide or spotlight any individual ship. So that data, it's important when we share data like this that we we're trying to anonymize it, so remove the vessel identification information while still retaining the parameters that are important for multivariate analysis, just draft, length, breadth, and speeds. So all of that descriptive information is retained, but the ship identification information is anonymized. So the time of the measurement, for example, and the very precise vessel parameters. So if people want the data, they can contact Transport Canada. Now the contact person isn't, I'm not sure who that is right now, but orally Kosandi Godin is available here, and she'll be presenting today. She can probably tell you who to contact. The data sharing will be subject to sharing agreements, though, so research purposes have to be approved. So
great, thank you, Dave. Doug, did you want to elaborate on that?
Yeah, Julia, thanks. I'll be quick. It did. Well, first, thanks to all the presenters. That was really, really informative and thought-provoking in many ways. It did occur to me when Dave mentioned that, and then some of the other parts of the other presentations is, would it be effective to talk about some place where we could find a clearinghouse for a place for people to go, if it's not the actual data, the links to get to those data, so that people can go to a centralized thing. And it could be Game On, that would be great, but this is not a self-aggrandizing thing whatsoever. Maybe something already exists, and like I said, it could be, you know, a repository for relevant data, or the links for how to get there, and how we might aggregate that, so people spend less time searching and more time doing.
Yeah, absolutely. That is a great idea. Perhaps something that the group can explore as an action item after the fact. There's a great question in the Q&A regarding vessel operator buy-in for voluntary incentive programs. And I think to perhaps combine some of the questions, incentives generally, how to get different companies to be incentivized to take steps. Is it financial? Is it be a good person? What is the reason behind, besides some incentives that have previously been mentioned? And I'll kind of toss that to the group and see who wants to bite.
I can jump in quickly from the kind of Vancouver Fraser Ports experience. So with our initial slowdown in 2017, we offered a kind of flat rate financial incentive to vessel operators to participate. And what we learned at the end of that trial was that the flat rate wasn't really the thing that was driving participation. It was other barriers, financial barriers. And so in our region, for the Harrow Strait Boundary Pass slowdown area, we have the vessels have to have a pilot on board. And so what was a barrier to participation was when the additional time that a vessel would spend slowing down would throw that vessel into sort of a over 8 hours kind of excess time period, where punitive costs would be applied in terms of you know, having pilots on board over 8 hours from a safety perspective. So rather than an incentive, what we kind of worked towards with Transport Canada was to establish a fund to reimburse ship owners for additional pilotage cost. And so that really had a significant impact. I think we went from 66% participation in the first year to sort of high 80s, and we've been maintaining that kind of high 80s, 90% participation since. The Port Authority also offers incentives for quiet technology. And so that's something, I think we were the first port to offer those incentives to ship owners that have technologies on board that might make their vessels quieter, add-on technologies. And I think there are a number of other ports now, that probably 2 others, that offer incentives for quiet notations. We feel very strongly that the more ports that can offer incentives, financial incentives for you know, efforts that ship owners make to quiet their vessels, then it makes a much better case for the sort of capital investment of new technology. So we're always trying to encourage other ports to think about financial incentives to those ship owners who really are kind of taking extra steps to make their vessels quieter.
Thank you, Orla. I see Chris has a hand up. So Chris, if you'd like to chime in.
Yeah, thanks, Juliet. Yeah, just to share some information on incentive schemes. Ourselves working with others, we recently prepared a case study. We're minded to submit it to IMO, to STC next year, but we tried to compare the cost of a real ship putting in place a noise management plan versus the potential cost savings attributable to an incentive scheme. And in this case, the incentive scheme that the ship had already participated in is the IAPH ESI scheme, which is in the process of incorporating underwater radiated noise. And from IAPH and the ports involved, we were able to get an idea of what that module of the incentive scheme is going to look like. And on our calculation, it looks like there would be a slight financial benefit to the ship. You know, when you compare the cost of putting a noise management plan in place, which in this case is principally the noise measurements. They had to employ a local university to do the measurements. And you compare that with the saving in port dues, we found a slight financial benefit. We'd like to do more other ship types, other incentive schemes, and build up more case studies. But yeah, just wanted to share that with you. Thank you.
Thank you, Chris. Vanessa.
I just wanted to share the incentives that were going on with the Blue Whales, Blue Skies program. In the earlier years, they started with a financial incentive. It was not a reimbursement at all. It was just a small financial award, which kind of got the attention of the shipping companies. But right now, they actually decided, or they spoke with the shipping companies, and to keep the program growing, they asked, do you really need this? Or could we exclude it this year? And the shipping companies were fine with not getting the financial award. And so the incentive right now for the Blue Whales, Blue Skies program is solely positive public recognition, marketing, the New York Times, the LA Times, and local newspapers, which has kept the participation for these big shipping companies in the Blue Whales, Blue Skies program. So it's a really creative incentive approach, and it doesn't include anything financial anymore.
That's super interesting, marketing using public press. I think that's definitely unique and something I haven't heard of before. Rachel and then Eric.
Yeah, similar to what my Pacific Coast colleagues have shared, we found that in Washington, we don't offer a financial incentive, and it's been fine. But I want to put in a plug for anyone going to the Green Tech Conference. My colleague Sarah Adams will be presenting her master's thesis research, where she interviewed various folks all along the decision-making chain of the maritime sector, from ship agents to ship operators, to pilots, to other folks, to determine factors for participating in voluntary vessel slowdowns.
That's very interesting. Eric, as you go to finish answering that question, I'm wondering also, we had a little question in the chat specifically interested in how you think this could apply to developing countries in the global south. If you dare to elaborate on that a little bit.
As well, yes. Yes, just quickly, I like to support Orla's statement, and I not only myself, but we are a lot of trying to encourage other ports to replicate the eco-like incentives in Europe, because this is very direct, very understandable. But another promising feedback I like to share is 2 tankers ship owners with more than 200 ships. When I talked with them about underwater noise and this similar representation and the noise ship index and so on, they say, oh, But this is perfect for our ESG reports because we are asked for quantifying our actions. And that's what they expect, even in a non-monetary context, to be able to do something, but to be able to prove that they are doing effectively something that is quantifiable. And this is more indirect, but this will come, I hope, more predominantly, because it's what is driving also the company's strategies on sustainability. And with regard to global south and developing countries such as Chile, if it's Manuel, if it's is not his last name, but his country, I don't know.
It is.
Yeah, okay. It is fully replicable anywhere. So there is no constraint about the country we are talking about. The methodology is the same. The approach is the same, and the ships are traveling worldwide. So wherever they are, they will be concerned in Cape Town or in Vancouver or in Marseille.
Great, thank you. Pivoting a little bit, in regards to Orla, your presentation, you shared about the 72-minute quiet period. There was a question about if this applies to continuous or intermittent sound.
I think that may have been to Rachel, actually. Was that
Perhaps.
you, Rachel?
Yeah, that was
I wrote
me.
it down incorrectly on my notes.
Yeah, sure. 72 minutes is sort of the cumulative additional time over an average day of the slowdown, but the durations of those quiet periods were between 5 and 63 minutes at a time. And I put a link to the report in the chat, or in the Q&A.
Wonderful. And throughout the Q&A, there are a significant number of requests for data. I encourage our attendees to reach out to these experts and see if they are able to share their data. This recording will be shared on the Game On website, so you will be able to access their presentations again and from there. But if you are specifically interested in a data set and it is not easily linked, I would encourage you to reach out to our presenters. With that, we actually are leading into our break. And so I want to say a big thank you to all of our presenters and encourage everyone to come back tomorrow because there will be more discussion tomorrow and our presenters will, most of them at least, will be there and will be able to continue this conversation and this important aspect of URN. So thank you, everyone. And regarding timing, we have a break now, a 15-minute coffee and tea break, and that will extend until 12:30 Eastern time. And so hopefully that is an easy transition to wherever you are in the world. So think 15 minutes from now or 13 minutes from now. And so feel free to stay in the room and we will be back for session 2 at 12:30 p.m. Eastern time. See you all then, and thank you so much again to all of our wonderful presenters.
Okay.
Over to you, Molly.
Thank you. I'd just like to thank the presenters in session 1 again so much. I hope that everyone got a good sense of the current efforts in support of these target setting. This next session will really delve into the implementations of these efforts, and we're looking to find synergies between ship owners, builders, designers, regulatory bodies, member states, and other stakeholders as well. So we really want to highlight and share insights on regulatory differences, challenges, but also solutions, best practices, and all of this is to, again, leverage effective noise management across jurisdictions. So we are very lucky to have an eclectic group of presentations. Just as a reminder to the presenters for this next session, please just do a brief introduction of your affiliation and relevant work, and then we'll dive right in. For any attendees, again, please use that Q&A. We'll collate the questions, and we will have about a 15 to 20-minute Q&A session at the end of all the presentations. So first up, we have Aurélie Kosandi-Godin from Transport Canada. If you could pop on camera, Juliet will be running the slides. Thank you.
Wonderful. Thanks, everyone. So my name is Aurélie Kosandi-Godin, and I'm a policy analyst with Transport Canada Marine Policy Team. So pleasure to be here with all of you and to share a little bit more about our approach to URN management planning, some of the recent policy development, research, and supportive action. Next slide. Okay, thanks. So just very briefly, Transport Canada's mandate includes a broad range of environmental responsibility, including the management of URN. And Transport Canada is taking a really multifaceted approach to address URN. We've been combining operational measures, so both using slowdown, exclusion zones to provide immediate noise reductions, but we've also been working on longer-term technical solutions. So that includes the work we've been leading at the International Maritime Organizations, as well as our quiet vessel initiatives, supporting research and innovations of quiet technology. And as part of this work, we've also been committed to advancing URN management planning. Next slide. So in 2019, we held a public consultation on the concept of URN management plan. This was largely inspired by Canada's approach to pollutions regulations under our Canadian Environmental Protection Act. The focus was, really being on prevention at the source and promoting sustainable practice. So the consultation explored different key questions around what should those plans be applied to? Should it be applied to the fleet level, vessel level? Should it have a regional focus? Should we take some different type of approach, like a point-based approach? Who should it target? Should it be a specific sector, commercial? Should it be specific vessel class, the largest contributors of URN? And at the time of the consultation, there was not really clear preferences on the different approach proposed. Many challenges were raised, particularly with the actual international nature of commercial shipping. Additional feedback also emphasizes the need for further research, for more URN baselining data of ships, the consideration of financial and operational impact on the industry, and the need for further outreach as well. But as you've heard earlier today, the URN management planning approach has now been adopted by the IMO. It's in the 2023 revised guidelines on URN. And so in the revised guidelines in the appendix, you'll now have sample templates of noise management plan. Next step or next slide. Great. So to support URN monitoring and baselining of ships and research, Canada has made really significant investments in critical infrastructure. So you've heard earlier from Dave Haney on the West Coast, the underwater listening station has been active since 2015. This is in partnership with Transport Canada, the Port of Vancouver ECO program, as well as JASCO. And we've been collecting really a lot of data, which has been really instrumental to do research. Another project has been also developed on the east coast of Canada. It's called the Mars Project. It's located in the Saint Laurent estuary. It's led by a research consortium. They've been active since 2021 and have been receiving some support from Transport Canada as well. They are providing URN data that is aligned with deepwater ISO standards. So the two stations really differ in their configurations, and they also have different fleet compositions, both regionally. But despite those differences, we were able to compare those results, and we were very happy to see that they are comparable without an elaborated methodology. And there's about a 2 dB median variance between the two data sets. Next slide. Great. So Dave alluded a little bit to this, but a critical gap in our ability to measure ships was with shallow water measurements. So the data set that we've been collecting on the underwater listening station has been really critical in advancing the ISO standard for shallow water. where we know that major ports and shipping lanes are frequently located in shallow waters, so this was important to address. The new standards will come out this year. It offers much greater flexibility in the deployment methods and hydrophone configurations. And we know that as part of the IMO URN action plans, measurement standardizations is included, and we're going to likely continue working on this and developing further standards. One that we believe might be useful is around also opportunistic standards to allow to have even a broader uptake of measurements of ships. Next slide. Okay, so moving on into our work around developing reduction targets. So this was very much in response to our 2019 consultations. Transport Canada coordinated technical and policy working group focused on developing URN targets that could be used in the context of noise management plan. The starting point was the underwater listening station data, and we used the median value per vessel category. And those median values were used to derive a set of criteria or targets that you can see in the bottom right of the figure. There was a lot of conversations in that working group around, whether or not 50% is sufficient for conservation or biological needs. Should those be further regionally adjusted? Whether or not those targets could be met by all of the different vessels with current technologies, or using operational means such as speed reductions. A lot of the challenges for existing ships and retrofitting were brought up. The ability for new build to perhaps meet those targets or even surpass those targets were discussed. So a lot of good and interesting conversations also on how we should apply those if eventually it becomes regulations. How would you monitor? How would this be evaluated over time? So next slide. So we got multiple really key recommendations from this working group to conduct further studies to further enhance our understanding and refine our URN management strategy. There was a few key priorities. The working group preferred flexible targets or targets that allow some exceedance levels. And so there was a need to further evaluate how this would work, what would be potential implementations options. Also, the current conformance rates. So how, if those targets would be applied, how many ships would meet those targets currently? How would this differ regionally? So, for example, using the Mars data set, there was also discussions and recommendation to further explore and refine the approach of a single criterion to have multiple targets, and for that to influence or think about different policy approach to target setting. And also next steps, recommendations were to develop pilot project to test and refine policy, and then to do further stakeholder outreach. Next slide. So all of this research led us to refine a bit more our URN target setting in the context of noise management plan. Dave mentioned a few of those key updates, but it evolved from that single criterion that was 50% to having 3 levels per vessel category, which allows us to identify URN quartiles, so the quietest ships or the loudest ships. The limits were also further tailored to the ship type. So the top graph is showing you there's been a little adjustments to better match the actual true signature of ships. And then a conformance criteria was also established, so looking at a maximum of 5 dB exceedance in frequency band. Next slide. Okay, so all of this great work has led us today to our West Coast pilot project. So the main goal of this project is continue to advance URN management planning by focusing on real-world implementations of URN management planning and lessons learned. So we're really still at phase 1. We're sharing, our hope is to share the ULS data with ship owners so that they can start establishing understanding the URN baseline for existing SHIP and supporting the URN management planning. We're currently working on developing a specific report with them with specific, metrics and informations they need to be able to action their noise management plan. Phase 2 will really go towards supporting fleet level URN management plan and combining lessons learned. And through this process, we're very much looking forward to identify some good case studies to bring forward to the IMO experience building phase on URN revised guidelines. And we will also continue evaluating the technical aspect of this approach. And that's all. That's the next steps for us. Thanks very much.
Thank you so much, Arlene. That was great. Again, just a reminder, please put any questions you have in the Q&A and we will get to them shortly. Juliet is working on pulling up Niels' slides, and so we will have a perspective from the Netherlands. Niels Kinnegate, if you can come on camera, that would be great.
Yes, okay, good morning. Yes, I'm asked to give some perspective from this side of the Atlantic Ocean, and I'm Niels Kinnegate. I work at Rijkswaterstaat, which is a government agency in the Netherlands, but I'm also involved in the working groups of the European Union and OSPAR, and currently I'm project manager of a DMAS project, and that are in fact the three topics I want to address today. So European Union, OSPAR and DMAS. So next slide, please. Yes, first the European Union. Our legal framework for the European Union is the Marine Strategy Framework Directive that was established in 2008. And in fact, the basis of that, the basic idea of that is the good environmental status of European marine waters. And it is an ecosystem approach. So it looks at the environment, sustainable use of the marine waters, and it clearly states that cooperation is needed. So for marine waters, cooperation between member states, but everyone, all stakeholders. And it is in fact the first legal framework in which underwater noise was explicitly mentioned as a kind of pollution. So that was a major step forward. And since 2008, we have done a lot on implementing this framework. Next slide, please. So, and one of the steps in that was that in 2023 that we established threshold values. And in fact, the threshold values to be addressed is in fact threefold. It first, of course, is considered to be the noise level, the level of the noise, but there is also a temporal scale and there is a spatial scale in the threshold values. So you have in fact the assessment that has to be done has to look at those three values. So the first one is the noise level, and that's expressed in the concept of lobe, already mentioned, level of onset of biologically adverse effects. And as Brandon this morning already said, that it's very hard to say what it is difficult to put threshold values on effects and on the impact of noise. So it is still ongoing work in defining lobe, in setting lobe, and what it is actually is. Next slide, please. And also in fact this, no, you may go back, it was only this, yes, back one more. In fact, this is this sentence is the threshold values definition. It is some text that needs some time to digest. So I pick out something. So first lobe, and now it says the temporal scale, and it says that it should not be exceeded in any month of the assessment year. So it looks at noise levels in every month, so to express the seasonal variations in noise. And then on the next is in fact the spatial scale. Next slide, please. and it says that it looks at the habitat size and it looks at that noise levels should be within the principle of 80% of this on the carrier capacity or the habitat size of the area. So there is a limited amount of the area that may be exceeding noise levels, but not all. So that gives that flexibility. So next slide, please. So then the second part, of course, that MSFD says that regional cooperation is very essential. And for the Netherlands, our regional sea convention is the OSPAR convention, and that is actually covering the Northeast Atlantic, and it looks at a lot of aspects. It is in 2023, OSPAR published, I think, a major quality status report in which in fact the quality of the sea environment is assessed, and noise is one of the parts of it. So maybe I have the next slide, please. And then, of course, the major point, the major progress that we made in the last years is that we, as a noise group, we developed a regional action plan. I will go into a little bit of more detail. It is now, in fact, in the final stages of being adopted. So on next month in Spain, there's a ministerial meeting, and we hope and expect that at that meeting the regional action plan will actually be adopted, and then of course we start doing the actions itself. So going to the next slide, please. And we have taken 8 actions on different topics of underwater noise, and each action already has defined a number of activities inside. So it's a quite elaborate action plan, and it is a plan for the next 10 years. So in fact, very much important is action 1, in which we look at the targets and thresholds. So what do we want to reach, but also how do we implement that MSFD threshold values. And of course, in this case, action number 3 is looking at commercial shipping, and very much in focus in this action plan is that we want to support, of course, the IMO efforts and give contributions to the experience building phase of the guidelines, and elaborate on possibilities to reduce shipping noise as well. So that's a major point in our action plan, where we also consider other types of underwater noise. So maybe the next slide, please. That is in fact on actually implementation. So we have defined a project in which collaboration has been established between 9 parties in different countries. This is focused on the North Sea. So we have different countries: Belgium, the Netherlands, Germany, and Sweden. And we hope also to engage Norwegian partners in this project. It is a continuation of the Jomopans project that has been run till 2022, and so we decided to go on with this. So I will tell something about it because it's really related to the policy of and implementing policy. Next slide, please. So it has three word packages, and the first one is say that the main goal is that we want to have a policy advice for marine noise management, so that the policy makers who are not specialists in underwater noise, that they get clear advice on what can be done, how effective are certain measures, but also what is going to happen if with the current developments at the marine environment and activities at sea, because there's a very much developing a lot of going on, especially on the North Sea with human activities. Next slide, please. Yes, so what we do to do that is, in fact, we develop scenarios of mitigating scenarios and how to reduce, for instance, slow steaming, but also addressing certain areas to be especially protected from noise. Those scenarios will be input to a kind of a modeling scheme similar to what we used in the Jomapan scheme. So to also get the spatial aspects of the noise visible. And we want to include also biological effects into a kind of risk assessment, and that finally results in the policy advice. Maybe next slide, please. And these are the three word packages. So we have word package 1, which develops the scenarios, different scenarios and possibilities and options, and gives eventually the results. Word package 2 is more the technical part, so calculating sound maps, evaluating different and comparing different scenarios, what works good and what works not that good. And word package 3 is focused on the biological part of the underwater noise, and all is supported by data analysis, measurements, etc. So maybe next slide, please. So now word package 2, it is on modeling and measurement. So on the left side, I've shown an illustration. We have a lot of recreational vessels in the coastal zone without much AAS, so we cannot track them down. And so we made models on to predict, to estimate their spatial distribution along the coast, and also to estimate their typical speed and noise output, and thereby making those noise maps. While for the commercial shipping, we use instead AAS data to predict their speed and to get their speed and spatial distribution. And that's also supported by measurements. So we have on various places, we have a lot of measurement stations that can be used to validate data and also to identify source levels for different sources. Next slide, please. Now the word package 3, as I said, is the biological part, and what we saw is that well, there are hundreds of species to be looked at, so we have to select certain species. We call them indicator species, and that we want to evaluate and do the assessment for, and we want them to be representative of the whole ecosystem. So we have developed now a scoring system where we consider different species and say what is their value. So there is a kind of scoring on, for instance, vulnerability. So if a species is vulnerable, then it gets more likely to be assessed. And also, but there is also the issue of, is there data? So data quality score on the horizontal axis. So therefore we can say various species and why we want them to be included, and if it's possible to be included, of course, because of the data we have. Okay, next slide, please. So these are the first outcome of some subset of the species to be looked at. So, for instance, an amount of marine mammals, fish, but also invertebrates, and that are especially suited to be evaluated. And maybe we are now in the process whether we want to do this and where we can get all the information on these species distribution and that kind of thing. To be included in our schemes. Next slide, please. So, okay, that's all, because then eventually we hope to have a policy advice, and that the policymakers can say, well, these type of measures will work, and we want to implement them. So, in maybe as a final remark, then a lot of presentations were on the URN, which is of course important, but this is more focused on the receive levels. So it is on the levels in the water and not the output of shipping. And of course, we have to translate back to that in certain way if we want to evaluate measures. But that's something to be done later. Thanks.
Thank you so much, Niels. That presentation was great. Next up, we have Chris Waddington from the International Chamber of Shipping. If you could please come on camera.
Yeah, thanks, Molly, and thanks for inviting me. It's a pleasure to be with everyone today. Next slide, please. So to introduce myself, I'm a naval architect by background. I'm in my 4th year with ICS. ICS, or the International Chamber of Shipping, we're now in our 103rd year. We are the International Trade Association for ship owners, and our membership consists of 40 national ship owner associations representing over 80% of the world merchant fleet. And we represent our members at various international forums, including the International Maritime Organization. And we also produce various best practice publications for the shipping industry. Next slide, please. So the objective of my presentation today is to raise awareness of the opportunity that our decarbonisation efforts can provide for attaining reductions in URN. And firstly, I'll give some background to the global levels of ambient URN, and I'll then discuss the strong synergies between most fuel efficiency measures and URN reduction, and how these can be leveraged to implement a pragmatic approach to URN management. And I'll also assess how closely this approach can take us to the global target for URN reduction that has been proposed by environmental groups. Next slide, please. This graph is taken from a 1993 article by Donald Ross, and Ross was active in developing techniques for the quietening of US submarines and was a prolific writer of technical papers on URN, which are often quoted in the current debate. This particular graph plots ambient URN levels within the oceans against year, and it broadly reflects the 3 decibel per decade increase that environmental groups repeatedly highlight. And advocates of URN reduction have suggested that this trend is likely to continue, and for some regions there is evidence to support this view. However, recent analysis of deep ocean sound measurements by the Pennsylvania State University and the UK's National Physical Laboratory have indicated that this is not a universal trend, with some regions recently seeing static or reducing levels of URN. Some scientists have postulated that energy efficiency measures, for example, speed reduction, could be contributing to such URN reductions, and others have suggested that natural phenomena may be the main cause. Next slide. As far as I am aware, the only global target for URN reduction that has so far been proposed is by the environmental group, the Okeanos Foundation, and this has been previously endorsed by the International Whaling Commission. And Okeanos' proposal is to reduce the contributions of shipping to ambient noise energy in the 10 to 300 hertz band by 3 decibels in 10 years and by 10 decibels in 30 years. And this aims to achieve a similar rate of decreasing URN that we have previously experienced as an increase. Next slide, please. Many of the fuel efficiency measures adopted by ship owners to meet the IMO greenhouse gas regulatory requirements are also known to reduce URN. And in 2023, IMO arranged an expert workshop to consider this interrelationship. To initiate the discussions, the consultant VARD submitted a report comprehensively summarizing over 100 efficiency measures and quantifying the approximate energy savings and URN reductions attributable to each. And as shown in this graphic, for about 2/3 of the measures, there was clear synergy and co-benefit. For about a quarter, there was insufficient data to decide, and for the remainder, there was co-benefit. Therefore, in effect, energy efficiency is noise reduction, and with a little care in selection of energy efficiency measures, a welcome byproduct with little additional effort will be URN reduction. An example which illustrates this strong interrelationship is the 2016 modifications which were carried out by Maersk on 11 of their G-class container ships, and these were intended to improve energy efficiency and included the derating of main engines, fitting of bulbous bows, and installing propeller boss cap fins. URN measurements before and after the work were carried out on 5 of the vessels, and low frequency URN reduced by about 6 decibels. And of course, it should be noted that decibels are measured on a logarithmic scale, and a 3 decibel reduction is a halving of URN. Therefore, the 6 decibels achieved by Maersk, simply as a byproduct of their energy efficiency efforts, is substantial and impressive. Next slide, please. And here are some examples of the measures listed within the VARD report. Many of these can individually yield more than 5 decibel reduction, and for some around 10 decibels or greater are possible. It's also worth noting that IMO's carbon intensity indicator, which is a regulation intended to improve the efficiency of ships, is driving us towards IMO's 2030 target of 40% reduction in carbon intensity. On IMO's figures between 2024 and 2030, this would require a further 9% reduction in carbon intensity, or think of it another way, about a 9% increase in efficiency. And by comparison with this table, corresponding noise reductions of 5 to 10 decibels on individual ships appear a likely outcome. And to put the magnitude in context, please remember the Okeanos target for an ambient URN reduction of 3 decibels in 10 years. It's also anticipated that the recently agreed IMO greenhouse gas pricing mechanism will drive further improvements in energy efficiency through to 2050. Therefore, synergic URN reduction through to mid-century is a feasible proposition. Next slide, please. And these are the only energy efficiency measures I'm aware of that increase URN, i.e. optimization of the propeller blade area ratio, slow running of vessels with controllable pitch propellers, and ultrasonic anti-fouling systems. And care should be taken with these to achieve the best compromise between energy efficiency and URN. Understanding this is key to conveying simple industry guidance, i.e. the list of things that need to be avoided is very short, whereas the list of measures that give co-benefit is very long. Therefore, let's focus on these few aspects and provide detailed guidance on how to minimize their impact on URN. For the remaining measures, let's allow freedom of choice and prioritization of energy efficiency. The remainder give co-benefit, and so URN reduction can be assured. Next slide, please. Due to the complexities involved, it can be difficult to assess the overall impact of a global URN reduction strategy on ambient URN. Nevertheless, Ross has provided this useful equation to correlate the key variables for ambient noise. This includes terms relating to the average sound source level of individual ships, shipping traffic density, water depth, and attenuation factors. Of course, the real-life situation is more complex, but for purposes of predicting the magnitude of impacts and assessing sensitivities, the equation is a useful starting point. So let's use the Ross equation to indicate what would need to be done by individual ships to achieve the Okeanos target of 3 decibel reduction over 10 years. And Molly, if you could just step forward 1 click, please. So firstly, let's assume that we are looking at the deep ocean over the period of the coming decade, and average water depth and attenuation remain constant. So please click again, Molly. 1 more click, please, Molly.
Sorry, just making sure I'm getting it right with the clicks.
That's it. Thank you. Thanks, Molly. Now, on World Trade Organization figures, world trade increased by 36% over the decade 2012 to 2022. If we conservatively assumed a further 50% growth from 2023 to 2033, this would necessitate similar growth in ship traffic. and the Ross equation predicts a corresponding increase in ambient noise of about 1.8 decibels. Please click again, Molly. Thank you. And then rearranging the equation then allows us to predict approximately what reduction would be required to balance the increase due to trade, and then achieve the further 3 decibel reduction proposed by Okeanos. And please click again, Molly. Thank you. And this amounts to an average required decrease for individual ships of about 4.8 decibels. Next slide, please. So now comparing with the previous slide and noting the need for the industry to achieve a further 9% energy efficiency by 2030, achieving this 4.8 decibel reduction appears straightforward, so long as it can be achieved as part of a ship owner's efforts to decarbonise. For example, if well suited to the ship and its operation, the installation of air lubrication or wind-assisted propulsion alone could deliver the right magnitude of both energy efficiency and URN reduction. Hence, there's a great opportunity here to achieve URN reduction simply as a co-benefit of the energy efficiency measures which ship owners are increasingly adopting due to the progressive nature of the greenhouse gas regulations. Let's not make the excellent the enemy of the good, but instead let's adopt a pragmatic approach, readily delivering global reduction of ambient URN. And of course, this idea aligns closely with the Pareto principle, the idea that if we focus on key things, the most important things, we can get 80% of the benefit with 20% of the effort. Next slide, please. Thank you. And here is another comparison. The European Maritime Safety Agency recently completed an analysis of the current and the future URN levels in European waters. Their forecasts include various scenarios, including a consideration of the likely URN trends for 5 categories of ships, where the only driver is greenhouse gas reduction. And this graph on the right illustrates this scenario for the North Sea over the period 2020 to 2050. The 4 downward sloping lines are the predicted trends, URN trends, for cargo ships, container ships, ro-ros and passenger ships. The uppermost line is the prediction for tankers, and the black line is the overall trend for all 5 ship types combined. And as you can see, for tankers, the predicted URN levels go up steeply, and for all other ship types, there is a reduction in URN predicted of 10 to 80% in URN energy. A key driver for the increase in tanker URN is an assumption that tanker owners will prioritize propeller efficiency over URN, much more so than the owners of other ship types. And in effect, this aligns closely with the pragmatic approach I proposed in the earlier slides, i.e., in this instance, the key to URN reduction is to incentivize the correct behaviors with respect to the very few energy efficiency measures that increase URN. Namely, in this scenario, certain aspects of propeller design. Next slide, please. In summary, then, my proposal is very simple. Firstly, we raise industry awareness of the synergies between energy efficiency and URN, and provide detailed guidance on how to manage or avoid the few energy efficiency measures that increase URN. So long as these can be effectively managed, then the progressive GHG regulations will drive ambient URN downwards. Encouraging the uptake of the IMO URN guidelines and the adoption of noise management plans can formalize this approach and ensure measurable results through URN baselining before and after adoption of energy efficiency measures. And looking forward, there are several further measures that would be supportive of this approach. Firstly, a common approach to ship URN measurement. The recent IACS unified requirement was a good step forward, but more needs to be done, for example, encompassing IMO and ISO requirements and emerging technologies. Secondly, accessible and affordable ship URN measurement facilities. It can be difficult for a ship to measure its URN baseline. The few autonomous measuring buoys are a great idea. For example, the one that was mentioned by Eric earlier off the port of Genoa. But more of these at pinch points, for example, adjacent to the Suez and Panama canals, the Cape of Good Hope, etc., would be advantageous. Thirdly, tailoring incentive schemes to support the development of noise management plans. If the level of rewards from incentive schemes, for example, Green Award, IAPHE, ESI, NSI, etc., can be aligned with the typical cost of implementing a noise management plan, then the economics cease to become a limitation for URN reduction. Fourthly, greater accuracy and granularity in the definition of the URN impact of energy efficiency measures. The VARD report is very helpful, but the quantification of URN reduction is quite coarse and is not always based on tests or trials data. And then lastly, long-term measurement of global URN levels. This can easily be done and can be used to track our progress. There are already deep ocean hydrophones that have been installed to monitor the Nuclear Test Ban Treaty. Data from these has previously been accessed by Pennsylvania State University and the UK's National Physical Laboratory for their analysis of long-term URN trends. Next slide, please.
We have just 1 minute left.
Okay, nearly finished. And finally, here's some further information that may be of interest. On the left is a major study by Vahid, who spoke earlier, of Southampton University, into the synergies between energy efficiency and URN. This was sponsored by ICS and is freely available from our website. ICS has recently made 2 submissions to IMO on underwater radiated noise, and again, copies of these are freely available on our website. And on the right is the best practice URN guide that we have jointly developed with BIMCO. It's aimed at ship owners, managers, and mariners. Whilst explaining the adverse impacts of URN on marine life, it articulates this pragmatic approach to its management. And the guide can be purchased online via our website. Next slide, please. Thank you, and happy to take questions later. Thank you.
Thank you so much, Chris. That was very informative. Jesse Spence from Noise Control Engineering will be our next presenter. If you could please come on camera.
Yes, should be on now. Let me get, I think I'm presenting from my side, correct?
Yes, that's correct.
All right, let me just get it going. All right, so thank you. Thanks for the invite to present here. My name is Jesse Spence. I'm the president of Noise Control Engineering. I will be talking about the process of designing a vessel to be quiet, which also includes some background information on the causes of underwater noise. So there are essentially 2 big picture, I'll just say buckets that you can put different sources into that are really the main cause of underwater noise. One is going to be your propeller source, and then the other is going to be your machinery source. So just to dive in briefly here into both of those. So propeller noise really, it boils down to the formation or really the rapid collapse of cavitation bubbles. Cavitation is seen here on the right side, this image, the sort of cloudy area and sort of what looks like maybe like a film or something that's on the blade shown in the image. That is all different forms of cavitation. And cavitation is formed when the local water pressure drops below the vapor pressure, and that's a lot of words. So what does that actually mean? Well, so if we look at a cross section of a propeller blade, so in other words, in this picture here, you see the black lines. If you were to take a slice across one of those lines and then sort of imagine that you're looking at the cross section in the image in the lower right, you can see what's drawn on here is a pressure distribution. Suction is drawn, as a positive suction is drawn up in this particular case. And when a propeller blade works, it is truly pulling the vessel through the water as opposed to pushing. So it's really acting as an airplane wing that produces lift. And what that does is it creates a reduction in pressure on the blade. And as you can see on the right side of the image, there can be a region that exceeds the vapor pressure limit, which is then going to cause cavitation. And so the factors that modify what this distribution look like have to do with the blade geometry, how fast it's spinning, the flow into the propeller, and essentially just design details of the vessel. So, these are all very important things to recognize that, this isn't just sort of a magical sort of abstract thing. There are very specific causes for underwater noise, at least specifically the propeller cavitation. And it's also very important to understand that the hull form itself plays a critical role, not just in terms of setting up how much drag or how much force is needed to move the vessel through the water, but also in terms of the flow that goes into the propeller, and which then drives other aspects of the design. So I'm not going to get too far into exactly how you get to or how you go about designing a propeller, but there are many different approaches that can be used, ranging from spreadsheets all the way up to computational methods and model testing. These are all methods that are currently used simply to make sure that the propeller does what it's supposed to do, which is move the vessel forward. These tools are very much independent of the underwater noise that is created, but you can use these tools, or at least the outputs of these tools, to understand how much noise is going to be created from a particular propeller design. Machinery noise essentially boils down to different combinations of vibration that is imparted to the vessel structure directly by the machinery, and then also airborne noise, which gets into the water in various ways, whether it's directly through the structure or exciting the structure into vibration, which then ultimately radiates sound into the water. Once again, there are various design tools that are available and are currently in use, not just for underwater noise predictions, but for airborne noise predictions for the crew and for passengers. These are very common tools that can be used to assess the vessel design before it is even constructed. And similarly, there are many treatments that are available to reduce underwater noise. So what is the relative importance of propeller noise versus machinery noise? Well, it's certainly going to depend on the vessel type and the specific selection of machinery, how machinery is mounted, what the propeller design is, etc. Just as a simple example here, this is two different measurements from a tug. I'll just focus mostly here on the red curve, which represents operation at full power. And what we can see is at low frequencies, we have specific contributions from the propulsion engine, which happens to be hard mounted. In other words, the engine foot is directly bolted to the hull structure in this particular case. We do see a very low frequency, a component of what's called blade rate, or it's really just another propeller excitation. But then at higher frequencies, we have it's all cavitation. And so which is important, or which is more important, somewhat depends on exactly what you're interested in. If you're interested in low frequencies, then obviously your propulsion engine is going to be important. Higher frequencies, cavitation. If it's simply overall noise, as much as it may not look like it from this particular plot, cavitation, the summation of all this cavitation energy actually overwhelms the propulsion engine in this particular case. So I'll just keep on moving for time. Here is another example of a ferry. In this particular case, it is entirely propeller or cavitation driven, with the exception of this tone from propulsion motor. Although I will note that the diesel engines in this particular case have been resiliently mounted, and their presence, at least their outward presence in this overall plot, is certainly hidden. So, all right, so what is the overarching noise reduction strategy? Well, we have to understand the causes of noise in order to be able to reduce them. And this understanding is something that that marine design and acoustic specialists have. It is generally something that owners and operators do not, or if they do have it, I'd say as a general rule, they are not going to be acoustic or hydrodynamic specialists. And so because of that, we can't really expect owners and operators to identify the treatments that are going to, or this, even the mitigation approaches that are going to reduce underwater noise for their vessels. However, owners and operators absolutely have an important role to play when we're talking about reducing underwater noise. And this comes in essentially in a statement that they want to reduce underwater noise. What's shown here on the right side is sort of a simplification of the basic design and construction process. And really everything starts with the identification of a need for a new vessel. So whether that's we need to replace an existing vessel, or we have a new market that we're trying to satisfy, what have you, we say, okay, we need a vessel that can carry X amount of stuff, and it needs to go this speed and transit between these two locations, for example. That is part of what was really called the pre-concept design. And maybe just to cut to the chase a little bit, it is at this stage that the vessel owner really needs to say, I want to have a vessel with reduced underwater noise. Now, fortunately, as we just said, the owner's not going to be an expert in underwater noise. So we can move forward with that simple statement. Because during the concept design, the specialists that are going to be involved can then work to identify what's an appropriate limit, and then start to work towards how would we actually implement the design to meet that limit. And then as the vessel design moves forward, more of the details of the structure and equipment get developed. And at the detailed design and construction phase, this is where the shipyard gets involved and makes final equipment selection and actually builds the boat. And then ultimately we're testing, and the owner would then be required to maintain the vessel to make sure that their underwater noise is met. So that's a very 2-minute or less overview of the whole design process. And so, as we've already heard, the IMO has developed a management plan for owners and operators. So I'm not going to rehash the whole thing, but it has related steps to the conventional design process. So we're talking about determining a baseline, and then ultimately identifying underwater noise targets. And then we are selecting underwater noise reduction approaches, and then performing an evaluation after a vessel is constructed, and then ultimately monitoring. So we need a way to, or I'll say it this way, SNAME TNR 6-3 has been created. This is a document that's been created by the Society of Naval Architects and Marine Engineers to help sort of bridge those two items, the underwater noise management plan and just sort of the conventional design and build process. So this document aims to provide practical knowledge for owners, but also for designers and other stakeholders, just in the development and construction of quiet vessel designs. Again, it sort of provides that insight or that bridge into how can we implement the underwater noise management plan into something that we already are familiar with, the design build process, and then it also provides similar background information like what I provided at the top of the presentation here, as far as what are the causes and potential solutions for underwater noise. So overall, underwater noise is really something that has not been considered in most vessel designs. Certainly it is something that the Navy is very well aware of. There are some specialty vessels like research vessels that have been designed to meet varying levels of stringency with regards to underwater noise requirements. These are things that we can do now, and there are people out there that know how to design the vessel or vessels to be quiet as a general rule. What we have not done is really taken a good look at how to design a container ship, for example, to actually be quieter, to have significant noise reductions. And I know that some efforts have been performed. I think that those are maybe relative light touch, and just to see sort of can we change one or two parameters. Is there any low hanging fruit here? And I think that the general consensus is maybe not so much. But I think that if a wholehearted look or an attempt to look at the entire design was implemented, we might find some new and unique solutions, in addition to the various technologies that have already been discussed out there. I will also say that it's always nice to hear about what I would call sort of the happy accidents that I think have been mentioned a couple times in today's presentations, where a certain design feature has been implemented, which happens to reduce underwater noise, but it wasn't necessarily intended to reduce underwater noise. Those are always nice and provide some good insight into what kinds of things might be possible. I will say, though, that in order to have a systematic reduction of underwater noise, underwater noise is something that needs to be assessed during the design of the vessel, and can't just simply be ignored and hope that other design elements will simply take care of the underwater noise. So realistically, all stakeholders should have a basic understanding of the real causes of noise and the mitigation procedures, not necessarily the exact measures that are going to be implemented into the vessel, but what are the processes by which we can mitigate underwater noise. And that really comes through owners stating their need to reduce underwater noise. And by doing that, what they do is they enable the vessel designers to include underwater noise as part of the design spiral. And they can balance those factors, the underwater noise factors, with the non-acoustic factors. So ensuring that the vessel still makes speed, meets the efficiency requirements, and also hits underwater noise targets. The SNAME TNR 6-3 is intended to help and really inform owners and operators on the basic process. But again, it's so I guess it's really meant to be a practical guide to implementing the IMO's underwater management plan. Thank you very much.
Thanks so much, Jesse. Our last presenter for this session, we are lucky enough to have Sebta Bozdaging from the IMO. She will be